Welcome back, everyone. We are here for day 4 of the Go Cloud Careers completely free Azure Solutions Architect Expert Bootcamp to prepare you for the Azure Solutions Architect Expert certification, specifically AZ305. We've been having a lot of fun for the last couple of days. We've been talking about compute, we've been talking about storage. We've been talking a little bit about networking. It's been a whole lot of fun, or at least it's been fun for me because I love going out there and connecting with the community. And I love when we do these free training sessions. Today, we're going to get involved in some more networking and more good stuff as it pertains to Azure. I want to remind you, if you've just joined today, maybe it's your first day, don't worry. You can go back and watch the previous Monday, Tuesday, and Wednesday. Also, want to remind everyone that in this first week, we're kind of diving into these Azure fundamentals, really explaining how all the underlying technology sort of works and what's going on. And in our second week of this, we're going to run through the Azure Architect training, where we're going to talk about more your design considerations and things to do from a design perspective. But we had to make sure that you understood the tech, because we deal with so many people who have 6 and 10 and 20 certifications, but they don't understand the tech. And if you can't understand the tech, there's nothing you can do, and there's nothing that you can do to design it. So that's why we did the level set. Now, we also do have hands-on labs for those of you that are, say, in an engineering world or a systems administrator world, and you can get them completely free. My team popped the link for these labs, which you can do on your own in the chat box. But our function is making sure you know Azure. Because when it comes down to interview time, someone's going to ask you about it. And if you can't explain the technology, you can't be hired for anything. So we want you to know you're there. I've interviewed 6,000 technology professionals over the last 25 years in my architecture roles. And it's very easy for me to find someone that can configure things. But when I ask them, how does the tech work? Why would I use it? How does it fit together, etc.? It's near impossible to find someone. And that's the skills necessary to be able to hire someone and want someone. So let me know that you're here. Tom, wow, it's good to see you back. Haven't seen you in a little while. It's good to see you. Phil, for those of you who are here, we are thrilled to have you. So let's go. Let's have day 24. But I need to know you're awake, alert, and oriented. So give me a hashtag AZ305. Day 4. I'm sorry if it sounded like it came out as day 24. Now, also, there's a lot of free things that our team has written for you. There's a guide on how to use certifications and which ones to get to align to your career. It's a free interview guide. Please go there and get it. There's lots of free materials on how to prepare for the interview and things to do and how to get your first architect job of all kinds. Architect interview questions. So go out there, check the description of these videos, and go get some of them. They are completely all free. So I look forward to joining you. And Yasu, Tom, it's good to see you. VJ, good to see you back. John McElwain. Boy, that's interesting. I know Lou in New York with a very similar name. Wonder if you're related. He's also in tech. Igor, I see you're in Poland. So we will begin now. So let's get into the fun. So yesterday, we ended talking about various things inside of the Azure VNet. And remember, the VNet, or your virtual network, realistically speaking, is your virtual data center where you're going to put your stuff, your company stuff. So if we put everything in our VNet, we're putting it inside of our company. And remember, in cloud computing, we have much less security options than we actually do in the data center. So a company may actually want to break their network into multiple virtual networks and then route between them. Or, you could have your company on Azure and another company could be on Azure, and you could just connect to them. And that's really what we're going to start talking about today is VNet peering. So what is it? Well, if I've got one virtual data center and I've got another virtual data center and I had a connection between them, they can now talk to each other. So that's what we're talking about with regards to VNet peering. It enables us to connect. Maybe I am an auto manufacturer. Let's pretend I am for a second. And then I have to deal with a tire manufacturer and a batting manufacturer and a steel company. They could all have their own VNets on Azure. And if I'm on Azure, I can connect to them through Azure without buying all these routers and switches and all these other things, because we can straight use the Azure network. So Azure VNet peering enables you to use the Azure network to connect to various networks. So Maybe we'll draw it out for you. We'll whiteboard it out a little bit so you can kind of see how this actually works in real time. So let's say this is me. And for right now, this is going to be Mike's server company. And let's say, I've got my VNet here. And Mike's server company has its VNet. Well, what do I need on servers? So maybe I need some CPUs, right? So AMD might be on the Azure cloud. Let's say Intel is on the Azure cloud, although most servers in today's world are going to be AMD. If anybody needs performance, because they're cheaper and they're typically much faster. Maybe I need a DRAM company. So let's say I'm dealing with Micron for DRAM. Maybe I need a hard drive company. Maybe I've got Samsung for hard drives because Samsung makes some great drives. Maybe I need some GPUs. Got to have GPUs, right? So AMD makes some great GPUs. While we're at it, NVIDIA makes some extremely good GPUs. And what's special about NVIDIA is the CUDA architecture. And not that the CUDA architecture is necessarily any better than AMD's architecture, but most of the machine learning libraries and machine learning things out there right now are designed for CUDA. That's why NVIDIA typically has such good market share. They are great GPUs. So now imagine all of these are on the AWS cloud or Azure cloud. So with VNet peering, what I'm doing is I'm basically creating a virtual wire effectively between these VNets. Oops, didn't mean to do that. And by having this virtual wire, I can now talk to AMD. And maybe I might need to be able to speak to AMD to place orders for CPUs or GPUs. Same thing. Maybe I need some CPUs from Intel, so I'm going to peer with them, and then they can talk to me, and vice versa. And by doing so, I now have connectivity to other organizations through VNet peering. So that's really what VNet peering is all about. Now, when we deal with VNet peering, we kind of have two options. We have the ability to connect with other VNets inside of your region, or we kind of have this global virtual network peering, which is basically connecting your virtual networks or your virtual private clouds or your virtual private data center. I don't care what you call it. It's the same thing across the global network across regions. So that's realistically speaking what we're actually talking about. Now, one of the things to remember is VNet peering is not transitive. So let me go back and explain what that means. In transitive routing, this is what needs to occur. Let's say this is VPC 1, 2, 3. So what normally for transitive routing to occur, and I'm going to just make up some easy to use IP addresses, 2.2.2.2. These are public addresses, so we're just making 3.3.3.3. Don't connect to these. So if we were to create a routing link between 1 and 2, 2 will know how to, this VPC over here will know how to reach this through a routing advertisement, say BGP. And if we had a link between 2.2 and 2.2 and 3.3.3, in non-transitive routing, 2.2.2.2 will know how to reach 3.3.3.3. But in non-transitive routing, 3.3.3 doesn't know that it can reach 1.1 through 2.2. And what is really going on in transitive routing versus non-transitive routing? For the users in 3.3.3.3 to reach 1.1.1.1, they both need a path, and clearly you can see we have a path here. We've got links. But they also need to know about each routes. So if 3.3.3.3 doesn't know about 2.2.2. knows how to reach 2.2.2.2, that's great. But if it doesn't know how to reach 1.1.1.1, what'll happen is the data would just be dropped at 2.2, so it won't work. So we have to understand that. Now, for transitive routing to occur, and most people that are familiar with networking are familiar with transitive routing. Like if we ran an interior gateway protocol such as OSPF, those routes would be propagated between 3.3.3.3 and 2.2.2.2 to 1.1. Everybody would know how to reach everybody. But in non-transitive routing, we have to fully mesh them, meaning we have to create a link between everybody. Now, for those of you that are familiar with BGP, you may note that interior BGP or internal BGP is non-transitive. And in order to make IBGP to work, what we either have to do is fully mesh our peers, or we can use something like a route reflector. So what does this now mean? It means that we've got Mike Server Company here, right? So I can speak to AMD because AMD and I have a peering session. I can also speak to Intel, and Intel can speak to me. But AMD can't communicate or hack Intel because we don't have transitive routing. So in order to make that work, we need to fully mesh everything. So fully mesh means everybody connects to everybody. You're all effectively one hop away. Now, here's the thing to think about. That gets real ugly real fast because the formula is n times n minus 1 divided by 2. Oh, yuck, math. So let's burn through. If we have 3 VPCs, we have 3 times 3 minus 1, which is 2. So 3 times 2 is 6 divided by 2. 3 VPCs, no big deal, right? Because we've got 3 peering sessions. But what if we have 10 VPCs? We have 10 times 10 minus 1, which is 9. So that's 90 divided by 2, which is 45. See how quickly it goes up? And there's limits in terms of the number of VPCs that you can pair with. So you can either create a fully meshed architecture where everybody talks to everybody, and that is a management nightmare, or you're going to have to do so versus a hub and spoke. And a hub and spoke architecture typically looks like this. And in a hub and spoke architecture, typically speaking, you would want, if this was your New York office, let's just say New York, and let's say this was San Francisco, SF, and if this is Athens over here, great city, and if this was Madrid over here, and if this was, say, Lagos over here in Nigeria, in a normal hub and spoke environment, New York can reach Lagos through the hub. But if we have non-transitive routing, that doesn't work. So how do we make it work? So initially, you could do fully mesh, which is something that's going to look like that. But there is also some other ways and some workarounds that we can actually do. So we have to basically break the rules of non-transitive routing in order to be able to create this type of a hub and spoke design. And what we're really doing is we're using something called VNet Hub, and that's going to support communications. We're creating this virtual RAN. So we have to break the rules of non-transitive routing, which means these spokes all learn how to reach each other because the hub here is actually exchanging routes in a transitive way. So that's what we're talking about. So when we get to a hub and spoke design, we have to use this. And we're going to basically use VNet Hub. And it's going to be a place that we can host services that can be used by different things. And by doing so, we'll break the rules of non-transitive routing and get our communication to work through just like we would in IBGP with a route reflector. So let's talk about some ways we could create a virtual RAN. We can have our branch connect to the cloud and that connect to something else like another VPC. We could have multiple sites connect to each other through a VPN. We can have private connectivity where we can have an express route or a private line to the cloud and then connect to other VPCs. So there's lots of ways that we can do this. And a hub and spoke design, let's be fair, you're all familiar with it. Even if you're not a networking person, any of you guys like to fly? Now, I live in Florida, so let's say I want to go to London. I get to go to the Palm Beach airport, I fly to Atlanta, and I go from Atlanta to London. Or if I'm in England and I want to go to Greece, no big deal. I go straight from London Heathrow to Athens. But what if why can't I just go from Palm Beach to Athens? There's no flight plans because airlines use, typically speaking, a hub and spoke design. You go to their hub. Delta Airlines has a hub in Salt Lake City, Utah. It's got a hub, for example, in Atlanta. Houston has a hub in Newark. It had a hub in it's not Continental Airlines, which is now United. They have a hub in Houston. They've got a hub in Newark, meaning if I want to go to London through United Airlines, I'm going to go from Palm Beach to New York and New York to London. So hub and spoke, I kind of hope that kind of makes sense. And when we use this virtual WAN environment, where we use this virtual hub, this network hub, what it's doing is it's enabling us to create this type of wide area technology network. So peer-to-peer transitive routing breaks the rules and enables you to go from point A to point B. And we're going to have to do this. And what are we really using? We're creating a network, what's called an overlay network, on top of the actual Azure network, which already exists. So when we use Azure peer-to-peer transitive routing, that's the equivalent of, say, using Cloud Hub on AWS or Transit Gateway or a BGP route reflector that says, here you go, break the rules of non-transitive routing. We'll pass your routes on to whomever, and you'll be able to reach everybody through this book. So it makes your routing much more efficient, makes your architecture much more efficient because you're going through the central site. And when we deal with this peer-to-peer transitive routing, it kind of looks like this. We're going to have this hub virtual network, and basically that's going to be doing the routing between our spoke locations and our on-premise. So that's VNet peering and the various flavors of it. While we start talking about Azure networking, we're going to talk about the Azure Content Delivery Network. What is that? It is a content delivery network made by Azure, hosted by Azure. And what a content delivery network is, it's a network, first. And why do I say a network? It's not just caching servers that are sitting there. It's a caching servers that are going to ride a network with higher performance networking, typically speaking, the public internet. Remember the reason we use express routes or private lines over VPNs is we need guaranteed service. Well, the way typically these content delivery networks work is once you get onto the content delivery network, it's going to give you a private network or a semi-private network, or at least a network where you've got managed performance until you get to your goal. So we'll go back to this kind of thing that we were talking about in the past. Let's say we've got a user over here. We have the user Aguilo, and Aguilo is sitting in Athens, Greece, and Aguilo goes to this point of presence. That's where his content delivery is located because he wants to go to gocloudcareers.com. He types www.gocloudcareers.com. It's not at the point of presence. It's not at the local caching server. And it jumps on this content delivery network. And this content delivery network actually may also have better performance than the public internet. It gets answered, and then it gets cached, and it gets sent back to the point of presence, and Aguilo gets his information. But, 10 minutes later, Vigeli wants to get this information, and he's in Athens, and Vigeli goes to the point of presence, and it's cached, and it's there. So I know we talked about content delivery networks before, and we talked about caching, and we did it on the first day. So this is really just a refresher, and now we'll get into the weeds about the stuff that you need to know about the Azure Content Delivery Networks. First thing I'm going to tell you right now is if you use a single content delivery network on any architecture, you introduced a single point of failure. There was a point where half of India was taken down because everybody used the same content delivery network, which didn't make any sense, and the business didn't use most of them. More than one content delivery network, which didn't make sense, and like the whole country was down because Cloudflare had a BGP issue. Or was it DNS issue? I can't remember. I think it was BGP, which caused the DNS issue. So, single content delivery network, single point of failure. And that's why if you were to do, say, an NS lookup of Amazon.com, You may get CloudFront, you may get Akamai, another wonderful content delivery network, and you may also get Fastly, and there's others. Because even a business that sells cloud computing like Amazon wouldn't be crazy enough to put all their eggs in one basket and use a single content delivery network because they need high availability. So, hope that makes sense. So, to use the Azure Content Delivery Network, the first thing you need is an Azure subscription. You have to create at least one content delivery profile, network profile, which is really just a collection of content delivery network endpoints. And you want to create your CDN profiles, and you can use a variety of pricing tiers based upon what you need. So, the content delivery network will give you some benefits. First, by bringing in the content and caching it local, it's a better experience for the users, lower latency. And when it comes to search engine optimization for websites, which is important, the lower the latency, the better the site rank, and the better the user experiences. The Azure Content Delivery Network will also have some DDoS protections that it offers. It tends to scale very well for large loads of traffic because these are big CDNs. So, and if we want, we can even serve content directly from edge servers. Now, we've got lots of features and functionalities from the Azure Content Delivery Network. We have things like geo-filtering, HTTPS custom domains, site acceleration, file compression, diagnostic logs, and caching rules. So what is geo-filtering? Geo-filtering is basically limiting content based upon a set of rules. So if I only sell to people inside of the US and only the US, maybe I don't want to push my content to the rest of the world and pay for the content delivery network fees to get it there. Or maybe I have a product that's legal in the United States, but illegal in another country. Well, I don't want to be selling stuff in another country where it's illegal, so I could be using geo-filtering. HTTPS, custom domain. So we can make sure that the content delivery networks can use SSL TLS-based encryption to enhance our security. Let's talk about the dynamic site acceleration. Really what's going on here is that we're optimizing performance and reducing latency of unique content. And it uses the Azure portal, some REST APIs, and some client software development kits to do this programmatically. We can actually do some route optimization or TCP optimizations for those of you that know enough about networking to make this work. And now, if we're using the Azure CDN from Akamai, which is basically the Akamai content delivery network that Azure resells, now we can even prefetch the information and stick it on the edges of the content delivery network before the first request happens. So we went back a minute ago and I said Agilo in Greece, went to reach the first content delivery network and it wasn't there. But with the Akamai version, we can push it there, so it's waiting for the first user of the day. And we can also do image compression. So what happens, you've got a limited network performance. At some point, there's only so much networking piping. And some things can actually be squished along the way to take less space and uncompress when they get you there. So we can do some of that, again, with Akamai's version, because we've got multiple options of content delivery networks. File compression is incredible because it improves file transfer speed. And it can be so effective that I can remember many years ago when I started in networking, we had these T1 lines, 1.54 megabit per second. And they were about $3,000 a month. I'm not joking. And there was this company called Expand that had these compression boxes, and they would compress the traffic over the internet. And we were getting 8 gigabit per second on our 1.5 gigabit per second lead. So we got 4 to 5 times the speed that we actually had by buying nothing other than these 2 boxes to squish it down or compress it. And when it comes to compression, we have the option where the CDN passes the compress file, meaning your servers are going to compress it before it gets there, or we can actually use the CDN to do the compression, which is going to offload your servers. Now, with this, we've got diagnostic logs, right? And that's going to give us information and analytics about our storage account. We can go to Azure Event Hub and see things. We can look at our log analytics in the workspace. So when it comes to logs, we're going to have Azure Diagnostic Logs. This is going to be great. It's going to tell us what's going on, what's working, what's not working. And we can export these log data to, say, blob storage, a CSV file, generate a graph in Excel if we want. We can export the data to Event Hub and then correlate the data with other Azure services. We can export our data to Azure Monitor Logs and view data with the Log Analytics Workplace. So we've got some caching rules we can do. We can make sure that sensitive data is done with TLS security. You may think of it as SSL, but it's TLS, which is a more modern version of SSL. And we can make sure that when the web browser is connected via HTTPS, the browser will validate the website certificate. And when it comes to controlling how these files are cached, we've got caching rules that we can work with, and we've got query string type caching options. Caching rules is basically we set a global rule for each endpoint, and it's going to affect every single request to the endpoint. Or we could use a query string caching where basically users can set up one or more caching rules for each endpoint in the profile. Now, we honestly have 4 different versions of the content delivery network we can actually get from Azure. We can get the standard one from Microsoft itself. We can get a standard one from Akamai. Remember, Akamai is an industrial content delivery network company. We can get a standard one from Verizon, and we can get a premium one for Verizon. And let's be fair, there are companies that's whole focus is content delivery networks like Akamai. And they may have a much bigger focus on developing the world's best content delivery network as opposed to a cloud provider that's in 1,000,001 different businesses. So I wrote these down so you can look at them at a later point if you want to pause it. But you can see with the Microsoft option, we've got some, dynamic acceleration. We've got general web delivery optimization, large file optimization. I'll work on any TCP port. We've got global load balancing. We've got standard caching and customized rules, IPv4, IPv6. So you can look at this at your own time, but you've got some really great features and functionality from the standard option. But now let's look at the standard one from Microsoft. I don't know what happened there. Let's look at the standard one from Microsoft. We've got a little bit more here. We've got some geo-filtering to basically not send our information from someone else. Now we've got some DDoS, and I'm sorry, this is with Microsoft. We've got some DDoS protection. And basically the way a content delivery network does DDoS protection is if a request goes to the content delivery network and it's an inappropriate request, like a TCP SYN or a TCP half open message, the content delivery network will just drop it. So it doesn't hit our servers and it doesn't hit our network. So you can see we've got a lot of robust features there, including diagnostic logs. The standard content delivery network is very easy to use with Microsoft. You can manage it via REST APIs, .NET, Node.js, PowerShell. Easily integrates with Azure stuff like storage and web apps because it's an Azure offering. Now, if we start looking into here, we've got some different features and functionalities from Akamai. We've got a little bit more image compression, more optimization. We've got some different kinds of site acceleration. And obviously this changes, so you're going to want to look it up. But we've got lots of opportunities security-wise when we're actually dealing with Akamai. And different types of compression formats. And you guys can look at that at a time that's going to work for you. It's relatively easy to use. And what do you call it? Akamai is a pretty big standard when it comes to content delivery network. Now, of course, we've got some options from Verizon too. Verizon's an option. You can see this if you want to pause this at a later time and go look at the features and functionality. But we've got lots of performance, lots of optimizations from Verizon. We've got standard and enhanced versions. And if your goal is to learn the idiosyncrasies of these, you can go back to these slides later. But also, I strongly recommend going to the website because these things change over time. Now, if we're going to get into the premium content delivery networks, now you're going to start seeing a lot more stuff. We can, start enforcing mobile device rules, maybe the way you want different things. We've got more many more things to preload assets that we could to make sure they're cached before you get there than with the standard version. You've got lots of security functionality from the premium from Verizon Security in terms of various versions of TLS, geofiltering, authentication via tokens. We've got more analytics as well that we could potentially look at if we're also dealing with the premium option. So they're relatively easy to use, lots of things. So you guys can read that, and it's going to change over time. So I don't want to spend too much time focusing on that. I'd rather focus on the actual training of what we're doing. So let's briefly talk about Azure Front Door. Actually, I think we covered that already. Let's talk about Azure Network Watcher. Azure Network Watcher is a service to see what's going on in your network. It enables you to monitor the traffic. So if any of you ever worked in networking and you looked at Cisco NetFlow, and it shows you that these are the flows of traffic that have gone through your system, this access bliss block this, well, that's really the Azure Network Watcher that we're talking about. It's a way to get some diagnostics. Is your traffic being blocked by a firewall? Is it real? Your traffic not getting there from an overly restrictive? Do we have all this talking between point A to point B where we need to optimize the capacity? You get a lot of great features and functionality when you can see what's going on in the network. And we can monitor communication between, say, a virtual machine and an endpoint. And it's going to be very similar to flow logs. We can also use it as kind of a gentle protocol analyzer or a sniffer to kind of see what's going on from point A to point B. And what we'll actually get is logs, diagnostic logs. We'll learn about our network security groups. We'll learn about our traffic. So very good functionality that you typically get on an Azure Network Watcher. It's the equivalent of AWS VPC flow logs, which is the equivalent of Cisco NetFlow back in 1999 and 2000. The cloud providers are trying to recreate it. So now I'm going to gently touch on BGP. I'm going to have Chris from my team drop a link to the BGP workshop. Me and my chief technology officer, Mark Milovanovic, we're both Cisco certified internet experts. We're both network architects. We did a 6-hour BGP workshop. Started out as a couple and we just kept having fun and kept going on. I need you to know BGP. There's going to be no jobs out there if you don't understand the BGP routing protocol, at least as an architect. I'll cover some basic intro level stuff. BGP is what's called an exterior gateway protocol, and it's used to connect to external entities. And we use BGP because it scales. Like the internet routing table is over 800,000 routes. And I might have my ISP router connect to 10 different internet service providers. And I'm going to get basically 800,000 routes or more from each one. So it scales. Whereas an interior gateway protocol like OSPF would break potentially at 10,000 routes or less. BGP can do 8 million. BGP is unicast, meaning the rest of these routing protocols discover their neighbors. With BGP, I have to tell it, I will connect my BGP router to Chris's BGP router, and we're going to have to agree on parameters. BGP enables me to tune it, that I can have two links, and I could say, this traffic goes over this link, and this traffic goes over this link. So BGP is an exterior gateway protocol, meaning connecting to exterior entities. And the cloud provider is an exterior entity. The internet, when you connect your business to it, is an exterior entity. So it's going to give you routes, otherwise known as network layer reachability information. Use this interface to reach that IP subnet. Use this interface to reach that IP subnet, what have you. And how it does that, and the finite state machine, and all this other good, fun, and exciting stuff, please check out that 6-hour plus webinar that Mark Milovanovic and I did. It's completely free. It's on YouTube, so go get it. And some other things to remember is that if you're going to use a direct connection or express route, you're going to have to use BGP. So here's, generally speaking, your alternatives. And I want you to understand why we need dynamic routing. Dynamic routing is going to enable us to know how to reach everything on the network, and it's going to self-heal itself. If I have two links and I've got a dynamic route, and this link goes away, the traffic will take the other link. Life's good. If not, it won't matter. So we can add static routing. And if I had 10,000 routers, I would have to go to each router and tell each router manually how to reach every single subnet. I got to tell you, that would be a nightmare. And every time a link went up or down, I would have to go to every single router and manually configure them. But the routing protocol talks to its neighbors. Are you there? What routes do you have? I got some routes. You give me some routes. And it builds this map dynamically. And it will self-heal. So that's why we're using BGP to connect to external entities, and the cloud provider is an external entity. Okay, so I'm going to add a little more, and then we're going to go take a break and answer questions. The next thing that I'm going to talk about are some Azure network performance optimizations. So I'm not going to necessarily call all this networking, but it's going to be considered networking. So anytime in network optimization is a technology or a means to improve the performance of what we have in our networking domains. And part of that is understanding what we have by monitoring and then managing what we have and then tuning things based upon our needs. Now, part of network optimization is making sure we have the right IP addressing plan. If we have the wrong IP addressing plan, everything is going to crash. And the wrong IP addressing plan is going to lay the path for your routes. If ever of you have ever been in a city where the city expanded because they didn't design it right, because they didn't plan it was going to grow, and you're in a city that have streets like this and maybe little cobblestones on the street, and now the city's got 5 million people in it or 3 million people, and you can't get down the street, that was because basically the route planning wasn't right. Most of the problems I've dealt with in my career are people didn't understand how to plan the routes and plan their subnets, so they designed it wrong, and then things came crashing down. So optimizing availability zones, optimizing your subnets, optimizing where your routes are, optimizing your routing and the routing protocols and what routes you share with where. That's what we're really talking about. Optimizing the perimeter of your systems to protect your systems from, say, bad actors, filtering out traffic into systems. So that's one of it. Now that network optimization, people like me literally spend, 25 years learning. So optimizing it like that's your CCIE, your CCDE, your network architects that are experts in network. Now this is more on the simple side. Now we're going to talk about optimizing where your stuff is in your servers. And we have this concept of proximity placement groups. And what are we really talking about here? Well, if I've got one server in New York and another server in London, the performance between the two of these and the connections is going to be suboptimal because we're going to have to deal with the latency of the wide area network. But if I had my servers all in the same rack, the latency between server 1 and server 2 will be negligible, a millisecond or less, where it may be 4 or 5 milliseconds across a wide area network. So that brings us into proximity placement groups, where we can place a single virtual machine or multiple virtual machines or availability sets very close to each other. And by doing it, we get better performance. But I want you to think about it. What happens if you put your stuff too close to each other and you have a problem in that area? Your architecture goes kaput. So understand, the closer you put your stuff together, the greater risk of failure. And I can remember working with banks that needed to shave a nanosecond. And we had 2 racks side by side of, all the servers and switches. And that way, it was close to it. But for optimal latency, you're going to put your groups in the same availability zone. For optimal resiliency, you're going to spread it out across multiple availability zones. So proximity placement groups is really basically putting your stuff locally and close together. So let's take a few minutes to answer questions, because the next phase is security and identity access management, and it's a completely new topic. Chris, if you bring me some questions. You've got some questions, let's ask them. Foolish the Crow, does hub and spoke create a single point of failure? Absolutely. So, generally speaking, when you use a hub and spoke, you create multiple hubs and multiple spokes in case one hub site goes down. Now, the reality is in the cloud, it's a little more resilient than it might be in the actual world. And the reason is in the cloud, we're using like logical routers as opposed to, say, physical router. So it's slightly better. But yes, hub and spoke sites create single points of failure. So in a high availability architecture, we may have 2 or 3 different single hub and spoke environments that we connect people to and set up our routing where priority routing goes here, but if not, go here. And so, yes, the answer is it will. And that's why it's not always the simplest architecture. Good question. Chris, you can bring in the next one. What is the difference between a content delivery network and a CloudFront distribution? So, a content delivery network is a network first of routers and switches and servers that delivers content to users and caches information. A CloudFront distribution is an AWS specific service that delivers content. That's it. So, in one cases, we're talking about a generic overall architecture and over technology. And a CloudFront distribution is related to a specific component of the AWS service. But a content delivery network on AWS and a content delivery network on Azure are pretty similar. Good question there. What is traffic mirroring? So here's what traffic mirroring is. And it comes out of networking. So let's say I needed to see all the traffic that's going through the network. Well, in reality, if we're using a switch, the only thing we'll see when we plug our systems into a switch, and don't get me wrong, all your systems are plugged into a switch, is we'll see the traffic coming from our virtual machine to whatever it's connecting to, and we'll also be able to see any broadcast traffic. So when ARPU has the MAC address, or it will be seen by everybody because it's broadcast, and that's all you would see. So if, for example, we wanted to see all the traffic that's going on, in a switch, we would have something called the span port. And what we would do is we would take all that traffic from the virtual LAN, like all those ports, and copy it to one part, mirror it there, so then we could run a scan or a protocol analyzer that looks at the traffic on there. So traffic mirroring, but in this case, it's not a VLAN. It's sending all your traffic out one port or to one virtual machine or one something, so you can actually go look at that traffic and figure out what's going on in your network. And when things don't break, when things break and you can't figure out what's going on, is it a network problem? Is it an ACL? Is it a routing issue? Is it an application issue? Sometimes what you actually need to do is put a protocol analyzer, also called the sniffer, and you can see the server is getting the traffic, but it's doing nothing with it. And that's what we're using traffic mirroring for. Good question, though. When connecting two public clouds like AWS and Azure, is BGP? Absolutely. Anytime you connect one external entity to another external entity, you're going to be having to use BGP for the tunability. And that's why it's called an exterior gateway protocol, because it's not used in your internal systems, although it's used to connect you to other people. Although we might use iBGP internally, so I could take the routes from AT&T and then pass them on to Verizon if I wanted to, and that's why I would use iBGP if I wanted to provide transit, which is way above anything we're talking about here. Okay, well, So what I'd like you to do is give me a hashtag AZ305 so I can make sure that you're still awake, alert, and oriented. Every Thursday we run a webinar on how to get your first architect job of some kind. Today we had all kinds of fun telling people how to get their first cloud architect job. We run webinars on how to become a cloud architect, an AI architect, an enterprise architect. We love architecture careers here at Go Cloud Careers. So join us for one of these free webinars. I got to meet people all over the world, answer questions. They're live and on Zoom. So please grab it. And while you're at it, if you're going to desire to become a solutions architect or a cloud architect, there's a free document that we wrote, which you can get until you get to that webinar. It's going to tell you every single skill you need. And I promise you, they're not what you think they are, unless you've already been an architect before. And I don't want you to go learn the wrong skills. For example, architects don't code. We don't do Python. We don't do DevOps. We don't do SysOps. We don't configure things. Now, cloud engineers do. And if you're trained to be a cloud engineer and you want to be a cloud architect, you won't get hired. Likewise, if you're trained to be an architect and you're building business cases and leading large teams and you're managing stakeholders and you're mapping out business processes, that's not going to prepare you for a cloud engineering job. So join us for one of these webinars and we can help guide you. And they're completely free on their own Zoom. All right, so now we're going to start to dive into security. I don't have the opportunity to get anywhere close to the level of security we would like to teach you guys. We teach that in our Cloud Architect program, but we probably may have a security boot camp getting to some degree of security that'll be far, far, far deeper than we ever could provide in any cloud-based security program. We'll get much deeper. So when it comes to security on the cloud, the first thing we need to understand is this concept of the shared security model. Now, it's different in the data center. You own it all, but we can't do it all on the cloud because the cloud provider manages their network, not us, the underlying network. And we can do whatever we want in our network. And if the underlying network crashes, we're done. We can't manage the cloud provider's security of their own facilities. We don't have access to the hypervisors, so that, the security of the hypervisor, they do. We don't have the ability to patch the BIOS in case there's a CPU vulnerability of one of our servers. So we get involved into this shared security model where we can secure our stuff and the cloud provider has to secure their stuff. And you have to hope that they've done a good job securing their stuff. So generally speaking, what are we responsible for? Well, implementing our own identity and access management strategy and living according to the principle of least privilege, industry compliance for our business, our role-based access control to determine what kind of people can do what, who's allowed to use the system, what are they allowed to do, and then keeping track of it. We're responsible for our security tokens and whether we have more than one account. We're responsible for our own firewalls internal to our systems, our IDS, IPS system, intrusion detection, intrusion prevention. We're responsible for preventing DDoS attacks to our VPC or VNet, but we have no control over whether they get hacked or not, which is why you want to use more than one cloud. Our service catalogs, our multi-factor authentication that we've chosen to use on our system. So I like to think of it as this. Azure maintains the security of their stuff, like the cloud and the network backbone. You maintain the security of your VNet and all those things that you actually connect to. Which means you're responsible for your data, your endpoints, your accounts, your assets, that sort of thing. Our networking, our servers, our containers, our configuration. But a lot of that stuff is going to be based upon the service we're actually using between them. So in this graphic, you can look, in on-premises, which we have on the right, we're responsible for everything. If we're dealing with infrastructure as a service, like a virtual machine, we have to manage our information, our devices, our ID access, our identities, our network control applications. They're managing your virtual machines, their routers and switches, and their data center, their power and their cooling. Now, when we start getting involved in this platform as a service, which is more about you upload your code and it just sort of works, manage them. Look at, they're managing more. They're managing the host, the operating systems, some of your network controls, about half of it, half of your applications, and half of your identity. So they're managing more, which means it's out of your control, and you have to hope that they're doing it right. And then we run into software as a service platforms where pretty much we actually use somebody else's stuff, like Microsoft Office 365. We have to hope they manage and do everything right. And lots of times they do. And lots of times there's outages. But, in a software as a service environment, you can see pretty much they manage everything other than your information, your mobile devices accessing the system, your accounts, and a little bit of your IAM stuff. But otherwise, it's there. So, what goes into security? Well, a whole lot. And one of those components is identity and access management, but the rest of it is how you secure things. One thing that's necessary is to use the principle of least privilege. The military is great with this. So don't give people access to more information or things that they need to know to perform their jobs. So, do I have access to the ability to take down the Amazon website by going to their routers and going to one of their routers and go router BGP and their autonomous system number and remove some neighbor statements? Of course I don't. They're not going to give me access to that. But I can go to the management console and access my stuff, because that's the principle of least privilege in action. If you're a general or an admiral in the military, you may need to know this. But if you're kicking down a door, you don't need to know what spy planes are flying around the world that are not in your theater, what you're dealing with, or what's in front of you. So, principle of least privileges give people the least amount of privileges and rights to do their job. And the second their job changes, you're no longer an engineer, and now you're a manager. Get rid of all that access to that hardcore engineering stuff that you could use to damage the system, and now give you access to HR systems and finance systems and manager systems. So there's that. Now we can also use something called role-based access control. Chris, I did a video on role-based access control about 2 weeks ago. Please pop a link to that for people. But role-based access control is this. Imagine I've got an enterprise and it's got, say, 200,000 users. Now, I could do a couple of things. One of the things that I could do is manually, I could hire a whole bunch of people, like 1,000 people, and say, here, you add users all day, you add users, you remove them, you manually adjust each user's rights. Okay. Well, I don't know anybody that's crazy enough to spend that kind of money, have a team like that, and leave all that up to human error. So role-based access control is as follows. I divide my job duties into roles. Systems administrators need to access a certain thing. C-suite needs to access a certain thing. Standard managers need access to this thing. Other managers need to access this. So what I do is I create the roles or job functions. I give the right permissions to those roles. And then I hire a bunch of systems administrators. Billy Bob comes in. I add Billy Bob to the systems administrators. Felipe comes in. I add him to the systems administrators. Nikolaus comes in. He's a systems administrator. So I had him. And now they all have access to the permissions of the systems administrator. So the next technology is a firewall. We went through firewalls. We talked how they work. So we have this concept of an Azure firewall that is a cloud provider-based firewall. Remember, the cloud providers are in about 18 million different businesses. Firewalls are not their primary business. There are companies like Checkpoint, Fortinet, Palo Alto that do nothing other than make firewalls for the most part. And there's companies like Cisco that do huge amounts of security via them and have entire dedicated firewall and security teams. So most enterprises are going to use for these. But we have the Azure firewall, which is a firewall like anybody else's. It blocks all unnecessary traffic that filters out anything that doesn't comply, and we can use it. The difference is what happens with unknown and unknown threats, and that's where these enterprise-grade next-generation firewalls tend to be so much better. But with Azure Firewall, we can protect web applications, so to speak, by keeping unwanted people out. We can create policies for certain sites. We can create rules against bots and rule sets doing things. And the point here is that these These WAF type environments or network firewalls, they're designed to protect your systems behind the firewall by blocking unwanted traffic. But remember, most of the cloud providers' firewalls are not adaptive in nature, meaning if it's something they know about, they will block it, like a known attack, like a SQL injection attack. That's known. But if it's an unknown attack, most cloud provider firewalls are not able to handle it. Your credit card company is an example of anomaly protection. So here's signature protection. Signature protection is, you've seen this information before, it's bad, stop it. Anomaly protection is much like your credit card. It's a lot smarter. When I first started traveling for work as an architect, and I went, here I'm in New York, then I'm in Dubai, then I'm in Australia, and I'm spending money in 3 different countries in each week. Initially, the credit card company would call and say, and shut off your card and say, that we've noticed a sign of fraud. And then afterwards, when I said I'm an enterprise architect and I do 200,000 miles on consulting, they didn't block anything. And then poof, one day I had to buy some physical therapy gear for a gym, and it was a huge purchase. Boom. Mike, did you mean to purchase this? Yes, I did. Okay, charge goes through. That's anomaly protection, and that's what the best of the next generation firewalls do, which is why we typically use them. But the standard Azure web application firewall gives you layers 3 to 7 of filtering, meaning the network layer, what do you call it? So the network layer, layer 3. We've got the transport layer, layer 5. The session layer, which is what do you call it? Layer 5. The presentation layer, which is layer 6, and the application layer. And what these do is they get filtering from Microsoft Defender threat intelligence feeds, and that's going to give it information. Block these addresses, they're known to be bad. Block this stuff, it's known to be bad. Now, there's a premium-based Azure Web Application Firewall that's got signature-based information in it. So, with regards to the signature-based information, now it's like, here's the known attacks that we prevent you at. So it's kind of like your antivirus. It's great. It sees something that it's been told about, it works, but it will not protect you against day 0 or attacks of unknown and unknowable circumstances. And that's why we typically use enterprise-grade next-generation firewalls. That's the reason. Let's talk about Microsoft Defender for Identity. And what is that going to be? A threat protection solution that aids in the eliminating on-premise vulnerabilities to prevent attacks, helps the security operations teams prioritize their information. It identifies and resolves and responsibilities and assesses threats for you. Let's talk about Azure DDoS Protection Standard. It's a technology that's going to protect you against distributed denial of service attacks. So what is a distributed denial of service attack versus what is a denial of service attack? Let's whiteboard that out for you. Sorry, my allergies are a little sniffly. Bear with me a second. I adopted this cat to make my wife happy, and I'm highly allergic to cats, and I love the cat. She sleeps basically over here with me every day, so I wake up with allergies, but love the cat. So here's the denial of service attack. So let's say we've got Hal the Hacker here, and over here we have our website, and bear with me, I'm going to share it. So let's say this is my website. My website is capable of handling 10,000 requests per second. So what Hal the Hacker does is he launches 20,000 requests per second. But the website can only handle 10,000. So what happens is the website is so busy dealing with Hal the Hacker that it can't serve its real customers. That's a denial of service attack. Now, a distributed denial of service attack is Hal the Hacker goes out there and he or she, whatever, infects a whole bunch of servers on the internet. So now Hal the Hacker affects hundreds, if not thousands of servers. Now we've got these infected servers, and maybe they were infected with a bot or something, or some malware. And now these infected servers all launched the attack on the website. So now maybe they send 100,000 requests each, and this can turn into something big. So that's typically a distributed denial of service attack. There's lots of things we can use. If we understand the way TCP works, we can send TCP send messages and half open messages, but that's way beyond this. That's more security architect scope. And any of the real architecture is outside of any certification. So that's what a DDoS attack is. So with Azure DDoS Protection Standard, what it really does is it looks at your traffic and makes sure the packets are real packets as opposed to TCP half open messages, which can crash a server. It ensures that like pings of death don't go to servers. It can actually rate limit the packets as necessary. And it can kind of help. So that's standard. So it's going to give some decent protection. It's always going to on. It's going to look at analytics. It'll block stuff. And there's a team that can help you. So let me briefly introduce Azure Service Trust Portal. And that is really a repository that's going to be used to expose or provide customers information along with compliance documentation. So it's going to help you look and give you information based upon Azure's compliance information. It would be used if you want to understand, how Azure may support any of the compliance offerings that you may be doing. Maybe you're in an industry that needs this. And like anybody else, some businesses are responsible to adhere to ISO standards, the International Organs for Standards. Some organizations are responsible for the Service Organization Control Standard. You may want to be trying to follow the National Institute of Standard and Technology in this framework for your security, or you may want to use something more secure. You may have to adhere to, say, the GDPR for privacy regulations in Europe if you're dealing with business in Europe. Maybe you're dealing with the government and you have to deal with FedRAMP or the Federal Risk and Authorization Management Program. So that's really what we're talking about. Now let's talk about Azure Defender of the Cloud. Now that's going to be another service to help users prevent, detect, and respond to threats because it's going to give you visibility into your system. It will help protect users across your Azure clouds and other things. And that's going to be a free tour that's going to give you some security assessments and security recommendations. It'll monitor your security posture to see, what's going on. It'll make recommendations. Some of these recommendations are going to be great. Some of them are going to be meaningless because they're automated services. And it can defend your workload to a degree. It covers basically two things. It provides cloud workload protection and security posture management. So workload protection is when it's going to assess and look at your subscriptions and recognize things. It'll give you a security score and then make recommendations, do this, do this, do this. Don't think this is going to be enough for security. You're going to need to have security professionals. They're going to use tools like this. They'll be able to look at it. They'll be able to analyze it. And they may also want to use bigger and more industrial security tools as well. It also gives you the ability to provide some protections on your workload. So that's really what we're talking about. Let's talk about storage service encryption. What is that really? Well, it's taking the stuff that you have stored and it's encrypting it with server-side encryption. So whenever you put yourself on the cloud and it's stored, it's encrypted using AES 256-bit encryption and FIPS 140-2 compliance to encrypt and decrypt transparently. So standard, traditional levels of encryption that we're talking about. Good, solid encryption. And it's enabled by default on your Azure storage accounts, and it can't be deleted because why would you want to not actually encrypt your data? Let's talk briefly about a network security group. What is it? It's basically a firewall. And it's going to give you the ability to determine what's allowed into your systems and not. Kind of like an ACL, kind of like a firewall. It's a packet filter. And part of your security is making sure that your unwanted traffic doesn't need to go to where it's supposed to. So it's designed to filter traffic. Don't let this server talk to this server. Don't let this server talk to the other servers. So what you do, like any packet filter, like an access control list, is you create your rules. Allow any user to access the web server at 1.2.3.4 on port 443. Block everything else. It's something like that. Okay, now we enter the world of identity and access management. Chris, if you'd please provide the link to the recent video I did on identity and access management. So, what exactly is identity and access management? Well, it's determining who you are, what you're allowed to do, and keeping track of it. So, the authentication piece, are you who you claim to be? And that could be you as a user, or it could be one server trying to connect to another server. So, it could be as simple as a username and password. It could be multi-factor authentication. It could be your username, password, and your eye scan. It could be something you have and something like your ATM card. If you want to go to the cash machine, you pop in a card, which is something you have, and there's something which is your PIN code that you enter. So that's really what authentication is. Who are you? And you may see it abbreviated sometimes as auth N, auth capital N, and micro. So that's your authorization. I'm sorry, authentication. Now, I think that'll work. Authorization, by comparison, is what are you allowed to do? So I see Valerie's on the stream. I know Valerie real well. So Valerie's got permissions for this, for this, for this, for this, for this, and for this. Because I know him. He's allowed. But we got, God, I'm drawing a blank on names. We've got CJ, for example. CJ is allowed access to this and this, but not this. So that's authorization. What are you allowed to do? You'll often hear it referred to as auth Z. An authorization is granting permissions to the authenticated party if you know who they are. So you have to know who someone is before you determine what they're actually allowed to do. Now, the last component of this is actually going to be accounting. What did you actually do? So, Valerie came to my house in Florida. While Valerie was in my house in Florida, I gave him the keys to the car and full access to the house because I know Valerie. He's awesome. Great guy. He's over there in Canada. Super smart guy, super educated guy. But I know him, and I know him well enough that Valerie, you do what you want. Here's the keys to my car. You're done. That's the authorization. Now, my wife keeps a stock of food, and she keeps a stock of extra thing and guest supplies because my wife just basically wants to make sure everybody's happy. So after Valerie leaves, my wife then takes inventory and said, I need new toothpaste. I need new shampoos. I need this, 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 and this because we gave these to Valerie. And then she goes, buy more of it. And then the next time somebody comes and visits me, we're ready to go. That's your authentication. Who are you? Your authorization. What are you allowed to do? And accounting is what did you actually do? So I'm going to talk about the concept of a role. And what is a role? Not in terms of role-based access control, but what we're actually talking about. A role is an assignment that an owner can apply to a user, a group. So a role can be anything. Generally speaking, when it comes to roles, what we're actually talking about is a collection of permissions. So systems admins, like in role-based access control, generally speaking. Salespeople. Can't give your salespeople too much because they're going to give your trade secrets away just to sell something, for example. C-suite, access to other things. So it's a collection of permissions, generally speaking. Azure actually has 120 different roles for role-based access control by default. Why would Azure have so many roles that are so good? Well, they've been dealing with Active Directory, which is the primary enterprise authentication mechanism, for decades. Now they call it Entrada ID, but it's the same product. So chances are there's a role that's going to work for you. But if not, guess what? You can create your own role specific to your company and what your company needs. So with Entrada ID roles, we can use it for a subset of users. We can give some people the ability to create users and remove users, reset user passwords, manages license, manages domains. Now, there are a couple of key important roles that I'll tell you about in case they pop up on your exam. One is global administrator, the next is user administrator, and the next is billing administrator. The global administrator is the person who signs up for the Active Directory Entra ID system itself. And you become that global administrator, which means you can manage every single feature in Entrada ID, as well as all the services to maybe federate Entrada ID to other identity providers like Apple or Amazon or LinkedIn, what have you, or Facebook. You can also reset the password with the global administrator to anybody as well as any systems administrator, because that's kind of like the person that wears the crown on the top of their head, the king, the queen, what have you. The next important Entrada ID role is the user administrator. That's the person that can manage all aspects of users and groups, manage tickets, manage service health, change password, because they're an administrator. They're not the one wearing the crown like we talked about before, who was the global administrator or the chief, but they still are systems administrators basically that need lots of access to people. Now, then there's the billing administrator. They can make purchases, they can manage subscriptions, manage support tickets, and service health. Note, they can't change usernames and passwords or permissions for people, so they don't need as much, so they're getting less. So role-based access control is really a means to restrict administrative access to people based on users and groups, so you don't actually have to create various permissions for every single one that's there. We have to define the concept of a security principal in Entrada ID. And this is the person that defines the access policy and permissions for the users. This role basically enables core features such as authentication of the user or the appliance during sign-in, authorization during research areas, and the entity itself can request permissions. The security principal is an object representing a user group or a managed identity. The security principal gives you fine-grained access, and it can even support segregation of duties. So what is that, segregation of duties or separation of duties? Well, you might have a team, but you don't want to give any one person on the team the ability to do anything. So like in movies, you see like there's the football, the president's attached to something that they can launch a war from. And for the president to use it, they have to have somebody turn a key along with them. That's that separation of duties. In high security environments, you usually have more than one person there. So let's talk about some more different roles that we have. And when we actually think about it, and here's the way some of these things kind of look like. You can have the main role, that global admin, and then they can create a group of people that can have access to certain resources. So it's really what we're trying to talk about. Trying to see where our next. You know what? Let's pause there take some questions, and I'm going to get more into Entrada ID after we get back from questions. Let's see if anybody has a question. How do you launch an update template? So, to be fair, I'm an architect, and architects don't launch anything. We don't build anything, we design it. So, this is not my area of expertise on how to configure. But having said that, to update a launch template for an auto scaling group, you typically create a new version of the template with whatever changes you want. And then you update the other template by modifying its, and then you basically modify its configuration sessions. But I'm not a hands-on technology professional. I'm an architect. Architects don't really do these kinds of things. So that's why I'm giving you general overall terms with that. What's the difference between Microsoft Defender and Microsoft Security Center? So Microsoft Defender is more of a security solution that's going to provide threat detection and protection for your devices, networks, and environments. Where Microsoft Security Center, which is also part of Microsoft Defender, is going to be something that's going to give you guidance on whether your security is good, what's your level of threat protection. So the Defender itself was really designed to help you. And the Security Center was kind of designed to tell you what it thinks your security issues are, but it's not going to be a comprehensive list. It's automated to give you some benefit. I keep saying Entrada ID versus Microsoft Entra ID. No, it's the same thing. I'm thinking Elido or entrance, and I may have stumbled over my words there. Honestly, it's when you're the way I live is it's sort of like I know every vendor's technology and what it does and how it works. But with regards to changing names and all these new names that they come up with, you kind of need like a little thesaurus to bring out in you with you. But that's really what we're talking about. It used to be Active Directory, and that's what I usually refer to it as, because it's been Active Directory for the last 20 some years. You're having trouble between understanding the difference between ACLs and network security groups. Well, the reason is you don't have the ability to create an ACL in Azure. They only do security groups. So the difference, say on Amazon, with the difference between a network ACL and a security group, and then is as follows: an ACL on Amazon is a simple packet filter, meaning it's not monitoring the state of the connection. Meaning you're allowed TCP. So I can connect to server with a IP address of 1.2.3.4 on port 443. But nothing monitored me actually going into that device itself, which means there's no state. And remember, if you were here when I showed firewalls, how they keep state and allow your traffic. So because access control lists themselves don't keep state, you have to apply them in both directions, because how else will they know to allow the return traffic? Whereas when you're dealing with the security group and AWS, what you're dealing with that is basically more of a host-based firewall. You create the same access list rules on the way in, but if I am an allowed user to website A, it automatically knows to send my return traffic back because it's stateful. Now, when we're dealing with Azure, we're dealing with network security groups, which tend to be flexible about Azure environments. So they're more about controlling traffic to and from virtual machines or subnets. And they're much more like your typical base packet filter, your ACL type things. But it's the network security groups are very Azure specific in the way they do that. And when it comes to ACLs, for mounting people like me, an ACL is a packet filter. You're allowed to reach this and this. But there's also other types of ACLs. So, for example, you could have an access list in Windows, and that access list in Windows, for example, determines whether you're allowed to read, write, or full control access to an object. So, access lists tend to be not specific. That's why if you go to a router, it's called an access control list, which is a packet filter. AWS calls it a network ACL. When you get into Windows and Unix, they have permissions, which are also called ACLs. But they also have the concept of an ACL on the network. And that's why AWS came out with a network ACL. But it's just branding of really what we're talking about. An access control list is a packet filter. A network security group is a packet filter. But they're Azure specific. Good question. Does Azure have a concept like organizations? Yeah, you can create multiple subscriptions and do it. So let's talk about the difference between AWS organizations and something like that versus real security. AWS organizations basically is identity and access management. So you create a bunch of accounts and you're like, well, this account is allowed to talk to this account. Okay. Now, if you broke your systems up into multiple VNets or multiple VPCs, whatever the equivalent is per cloud provider, now this system and this system can't talk to each other at all, except for what you actually allow in. And then you can still apply an identity and access management strategy. So using organizations is one way to do it, but I'd like you to think about it this way. Which do you think is more secure? Letting somebody knock on the door of your house and say, I'm here and I'd like my way in. And then I check your username and password. That's identity and access management. Or which do you think would be better? In order to get to my house, you have to cross a 500-foot wall. And after you cross the 500-foot wall, you got to go past 500 meters of shark-infested waters. And then after that, I've got some archers pointing arrows at you. And if you can get past that, then you can knock on the door. That's the difference of real security versus this IAM security. If you broke it down into multiple VNets and then had a VNet peering policy, and then you had firewalls and IDS IPS system between your VNets, you can still have your IAM, but IAM's your last line of defense. It's not your best defense or principal form of defense. So yes, we'll get to it. Azure does have the equivalent of AWS organizations, but it's not going to be one of the more secure ways that you could do it. It's going to be a simple way to do it for people that don't network. So, Shani, we got to speak this morning. What's the difference between a cloud architect and an enterprise architect? Well, the enterprise architect is big, big, big picture. I put on my Armani suit each day. I spend half of my day with the C-suite. And the average enterprise architect knows very little about technology. The cloud architect, by comparison, understands much more of the cloud and is going to be more technical. So an enterprise architect is 80 to 100% business and upwards of 20% tech. A cloud architect could be 50 to 70% business and 25 to 50% tech. So it's there. So generally speaking, if you're an enterprise architect, you're more of an executive. If you're a cloud architect, you're 3/4 executive, but you're still technology professional. So generally speaking, for a cloud architect to move into an enterprise architect role, they're going to need much more executive training, much more business process re-engineering training, much more leadership training, much more business acumen training. Now, the way we actually train enterprise architects at Go Cloud Careers is we train them with our cloud architects. So people that train for us with enterprise architecture are learning all the business process modeling, all the business acumen, all the executive stuff, and they're still doing the classes with the cloud architects. And by doing it, when we train enterprise architects, they actually understand the technology, and they can take either a cloud architect or an enterprise architect. But generally speaking, if you weren't getting our training, You wouldn't be able to go from enterprise architect to cloud architect, and to go from cloud architect to enterprise architect, you typically need more business and more leadership training. We combine the two because I like agility in my career. Sometimes people throw network architect work at me, and I love it because I love networking. Usually they throw enterprise architect with me, and I do that. But sometimes if they want to give me some cloud stuff, I'll do it too. So I like agility. Architecture is its own career, and I like to do it that way for that reason. You get confused with S3 ACLs versus other ACLs. Look, there's basically two kinds of ACLs. There's one kind of ACLs that is permissions, meaning permissions, like when it comes to storage. In fact, if you're on a Linux machine, you type ls minus la, and you'll see that you may have R for read, or RW for write, or you may have X, which means you can also execute, that read, write, or execute type permissions. On Windows and Linux, that is a traditional storage ACL, the kind of thing that you might have with, say, S3. By comparison, the traditional ACLs, or the network ACLs that network architects like me think of, it's a packet filter. You can reach this server, but not this server through the network. I'm filtering what you're able to do on the network. I could see how that would be confusing. And that's the only time I've ever seen AWS come up with a good name for something. They called it a network ACL to truly separate it. And I think that was very smart. Otherwise, it's elastic everything. Great products and services, though. So, for best practice of control, access use token, well, when we're dealing with Active Directory and all these other forms, you typically get a token. So, Muhammad, I'm not 100% sure what the question actually is. But generally speaking, it's recommended you use Azure AD, otherwise as Entra ID, because that's going to integrate with everything. And you can still get tokens from it and do multifunctional factor authentication, conditional access. So generally, it's going to be more secure than using tokens just alone. Okay. Sounds good. Why do I think Azure is more popular than AWS in the UK? Well, chocolate, vanilla, strawberry. But let's talk about why or it might be. So Amazon has 1.5 million employees, and yet its net income is less than Microsoft does with 256,000 employees. That's something interesting. Meaning Microsoft makes at least twice as much with 1/7 of the people. So Microsoft has been around for decades, and they are known as experts in digital transformation, business processes, and Microsoft has a very businessy oriented approach in the way they do things. There's no enterprise in it that is out there that has not been dependent upon Microsoft for the last 2.5 decades for the most part. Amazon is a global retailer. That's their predominant business. And they also have web traffic. But they don't have as much experience, or at least people don't think they do, in the digital transformation world. The Azure message is very tech. I mean, the AWS message is very tech. And businesses don't buy technology for tech. They buy business enhancement. And Microsoft tends to speak more to their language. But Microsoft does more total cloud revenue than AWS globally, especially, I mean, they don't break it down between smart cloud revenue versus traditional cloud revenue, but it's, they do more revenue in cloud. But I think AWS is a great cloud. I think Azure is a great cloud. I think Google's a great cloud. Dell's got a good cloud. Cisco's got a cloud, and they're all fine. But first people I think about in technology are Cisco, IBM, Microsoft. They're your big players in digital transformation, or have been for the most part. Cisco much less than it used to be. So they're the first names that I typically think of. And if you're the CEO, the chief information officer of a business, and you have to pick a technology company, and you pick overall one of the most secure and most valued technology companies in the world, if and when there's a mistake that occurs, you're going to say, I went with Microsoft. We've been using Microsoft. Everybody uses Microsoft for everything. Our desktops are Microsoft. Many of our backend servers are Microsoft. Of course, we work with them because we know how to. We've got relationships with them. Generally speaking, that's probably why. But the great cloud, all of them, and I don't have a preference for one cloud over another. They're all pretty much the same thing. Somebody else's network in a data center that you rent space in. Okay, so let's get a little back to some of this Entra ID stuff. So it's the official IAM solution of Azure. And it's big, and it's been there. So it is a multi-tenant cloud-based directory. Stores your users, their users' rights, their users' permissions. And it's the same thing that I'm sorry, I don't want to give you statistics, that almost every enterprise has been using for the last several decades. It really is. And it's going to store information about your objects. It makes it very easy to create these profiles. Basically, it's a database, and it's going to have a set of rules or a schema that's going to define, the objects and the attributes that are covered there. It uses a very structured data store, like a database, and it's got the ability to query and index and see objects and their properties, much like a database. And it's going to be able to distribute your data very easily. Who uses this? Well, generally speaking, the people that do the IAM are your junior people. They are admins that are basically just doing technician work, adding users and passwords. The people that are going to be setting you up to use Microsoft Office 365 or those kinds of things, Dynamics CRM online solution, and app developers. So, what features actually work? I mean, pretty much anything you could possibly imagine in enterprise device management. My team actually made a list of me for them so you can really look at it. But everything from your application management to your authentication to things for your developers, the ability to do conditional access, domain services, hybrid identity, being on and off the cloud, governance of who can do what, reporting and metrics on what people did. So Entra ID is big because Active Directory is big. It enables what Microsoft called seamless sign-on. So what is seamless sign-on? And that's basically a service that will automatically sign users into the corporate device when during their corporate use. So like if you're already attached to the network, you're already attached to the network. And that means that maybe if you're authenticated in one means, you don't actually have to type a username and password. It makes it real easy to access cloud-based applications without on-premise settings. It provides a great user experience, and it provides lots of opportunities. And Chris, make sure we address that question related to mostly fake jobs, because they're not, and AI at the next break. And AI does have a big impact on engineers and other people, much less architects, and we can talk about why. So let's talk about this concept of seamless sign-on. It makes it easier for users. It makes it very easy to deploy and administer certain things. It works with any form of cloud authentication, like a password hash synchronization or a password. It's able to be rolled out to basically all of your users with a group policy. And we'll talk much more about this specifically in many of these Azure type services when we do next week. So it's really about signing you in. Once you sign into your corporate device, you may actually be able to access other systems. So what's really going on? What's going on is an account is created on your on-premise Active Directory server. So you log in on your data, you sign into your on-premise Microsoft AD server, And then that's going to give you access to the Azure cloud. Why? Because you're already authenticated to the domain. You can almost think of it like it's. So that's really what we're talking about. So seamless sign-on makes it real easy. You basically logged in and authenticated because you logged into your Active Directory server, which is the same as the Active Directory servers on the cloud called Entra ID. But the Windows one you have is managed by you. It's your full server. It's under your full control. Whereas the Azure AD, Entra ID is basically managed Windows Active Directory servers are sharing and giving you access to. So basically, you sign onto your machine, you're authenticated locally, and you get access to the cloud. Kind of like a single sign-on, but it's specifically related to signing onto your own domain and giving access. So let's talk about the difference between single sign-on and seamless sign-on. Single sign-on is a method that basically you use a single form of authentication. I provide my username and password to this, and I'm allowed access to every systems that I have. Seamless sign-on is a little different. I sign on to my corporate network through Active Directory, and now I'm allowed to use the Active Directory-based services in the cloud because I already signed into Active Directory. So it's a little bit different, but similar. So now we're going to talk about identity federations. What's an identity federation? Well, it's really when you connect to somebody else's identity platform and you trust it and you use their information. So I can create my own Active Directory services and maintain my own directories. Great, right? It is great. But what if I had a website and it was a global website? And I wanted to make it easier for my users to connect to my externally facing website. And I said, sign in with Google. And I created a relationship Google where I trust Google. You log in with your Google account. Google passes me information, and then you're allowed access to my system. That's federated identity and access management. It scales wonderfully. Because there's lots of good identity providers out there, and it's a convenience factor. But which am I going to trust more? My own Active Directory servers or Google's or LinkedIn or Apple, somebody outside of my domain? I trust me more than I trust an external entity. So understand that identity federations, levels of trust may vary. But federations are great, and they are usually designed and often it could be, you can sign on premises and it would push it to the cloud provider's information. But identity federations are typically designed for high availability, scalability, and ease of use and management because you don't have to manage all these identities. Azure Identity and Access Management is a crucial service inside of Azure for who are you, what are you allowed to do, and what have you done? So we talked about role-based access control, meaning you create systems administrators, you give permissions to the systems administrators, and then add users to the group of systems administrators. That's role-based access control. Let's talk about conditional access. Conditional access, which you can do with Azure IAM and all these, is to basically force additional security requirements on specific conditions. So I may let you sign in with a username and password to my main systems. But now you got to access something sensitive, and now I need you to use a token, for example, or multi-factor authentication because it's now escalated privileges. And identity protection is really some extra features that are going to detect and migrate some security risks related to users' identities, like maybe something was wrong. Maybe there was some suspicious behavior that someone did. So keep that in the back of your mind. Privileged identity management. Privilege is the people that can do more. So, any of you ever went to a router? And on the router, you start out in user mode. And you can type a show IP router, basic things. And all of a sudden, you want to configure the router. and you have to type enable, which gives you the privileged executive mode. And then there you can configure the terminal and add routes or links like that. That's actually what we're talking about. And of course, Azure's identity and access management solutions integrate with Azure. So, so that's there. So let's talk about some best practices. Treat identity as part of your perimeter security. Again, your identity is not enough as building big walls and things like that. Try to centralize your identity management platform somewhere. So all your systems are logging into one system that's going to determine who you are. Enable single sign-on so you don't have to sign in your users to 50 different systems. Generally speaking, best practice. Why? Because if you need 20 passwords for 20 systems, you know what happens? Your users put sticky notes on their desktop. So enforce a good identity strategy and potentially use single sign-on to improve the productivity of your employees. If you've got exposure to privileged accounts, meaning people that can do more, really limit that. Maybe enforce multi-factor verification for all users. Don't let someone use the password cat or dog. Make sure you're using good passwords and, implement a time and a frequency for passwords to be changed. So now let's talk briefly about Azure security tokens. And tokens play a real role in authentication and authorization. And token-based authentication is really about maybe I log into a system, they give me some token, and then I can access another thing. So when I'm using single sign-on, I'm going to log into something. And I want to access another system, it's going to request a token, and the token's going to be provided. Why are tokens so good? In addition to all the other things we're talking about? Because if you get access to a token, and the token's good for, say, 60 minutes, and after that it's no good, well, if somebody gets access to your token, they can only use your systems for 60 minutes. There's lots of different kinds of tokens that are there. Azure often utilizes the JSON tokens, meaning JavaScript Object Notation, for their security tokens. If you want to learn more about Java or JSON web tokens, the great news is you can go to the Internet Engineering Task Force page, IETF.org, and you can read the specification or the standard, which is RFC 7519. And that will give you more details than you've ever dreamed about JSON web tokens. We get tokens out of Entra ID. So they're going to be closely integrated with that new version name for Active Directory. Azure also token supports these type of OAuth 2.0 tokens and OpenID Connect kind of tokens that we're talking about. Azure's got ways to validate and make sure your tokens are who they're supposed to be, that they haven't been modified or faked or what have you. And we can use some token-based access control. We can revoke tokens if and when something happens with Azure's tokens. So security tokens are going to be one of those fundamental concepts of one system accessing another system, single sign on whatever. All right. Well, I think we talked a lot about Azure AD or Entra ID. So let's talk a little bit about Azure management groups. Actually, let's go to questions. Different cloud providers are using different terms for similar names. Yes, all cloud providers provide the same service, and some of them have crazy marketing departments that make up names that you don't know what they're actually talking about. Is the cloud architect supposed to know every single term? No. The cloud architect needs to know every piece of technology and how that technology works and what that technology does for business and how that technology is integrated with pieces and parts. And then we're going to lead an architecture team, which is going to include other architects and other engineers. And we can easily look up the name of something. So, that's the nothing piece. Like if you know you need a virtual machine and you understand what type of virtual machine you need and the processor architecture you need, And the DRAM that you need in that machine, it doesn't matter whether you call it a virtual machine in Azure, a compute engine instance on Google, or AWS calls it EC2. That's silliness. But you do need to understand that virtual machine. When do I use a virtual machine for a container? How do I harden that virtual machine, or how does the team harden that virtual machine? Which CPU should I use, and why? Why would I use one CPU over a different CPU? What is it about one CPU that would give me better single core or multi-core performance, and how does that performance affect? So you have to understand all the underlying, but we're architects. We don't touch the technology. So we don't need to know the silly names that people call things. In fact, a lot of that's going to be the difference between real cloud architecture and the more junior levels of architecture. We may create an architecture framework that talks about everything that needs to occur. But that nitty gritty little stuff, we're going to use junior people to go for that. We're not going to waste somebody. You're not going to take a $500,000 engineer and have them do vocabulary Google searches on the marketing names that somebody calls something. That $500,000 architect is going to be focused on the people, the process, the technology, leading that architecture team, working with the organization to re-architect their business processes. They're going to be focused on selling the solution and then motivating the team, not the silly names of these things. That's why we have to create a team, and we'll have some techies that are going to help us with this. But no, people like me, senior architects, we're not going to remember marketing names. We're going to focus on how the tech is, how it works, how it's integrated together, and what it's going to do for our clients, because architecture is really the process of trade-offs. It's not like, oh, this is a cool technology. It's like, okay, well, we've got the opportunity of using a virtual machine or a mainframe for this bank. This thing is going to do 500 million transactions a year. And you know what? For this particular thing, the mainframe's better. Now, with the mainframe, we lose this, this, and this. If we go to the cloud, we gain this, this, and this. But for this particular use case, the mainframe's a better option. And that's why mainframe spending is going up. At the same time, we might say, okay, well, for this machine learning-based thing, do we need a large language model versus a small language model? The large language model gives us this and this, but it's going to take much more computational power and it's going to cost us more. For this particular use case, I can use a small language model. So that's not architecture what you're asking. That's junior level minutia, kind of looking up those things. We got lots of junior people on our team to help us with that. But you do need to know how to design it and how to present it and how to sell it. You do need to know about which CDN, how to architect with CDNs and how to architect for security, that kind of thing. So the question is, why are the majority of companies posting fake jobs, and making it extremely difficult to get hired at this point? Let's talk about. And will AI replace most jobs? No, it will replace some jobs. So one is, it is near impossible to hire someone that's competent and capable on cloud. You give me 5,000 resumes and I interview all 5,000, maybe 2 of the people are hireable. Now, the people are going to have 50 different certifications in everybody else's career, but finding people that can do the job is near impossible. So some companies are posting jobs unethically that they don't actually have. So the second they actually have a job, they have a list of the 5,000 resumes that they can whittle through. That is not making it harder for anybody to get a job, but it's making it harder to discern which jobs are real versus which jobs are not. AI will not replace most jobs. AI will replace jobs that can be AI automated. The cloud architect, the security architect, the enterprise architect, and the AI architect, the sales rep, the project manager can never be replaced by AI. Why? Because I'm a cloud architect, the first thing I need to do is go talk to the C-suite and find the vision of the business that I'm trying to deal with. Then I need to go analyze their business processes and learn how that business works. The next that involves lots of talking, lots of discussion with leadership. Then the next thing I need to do as an architect is try to re-architect those business processes or how they want that business to architect. Then as an architect, I got to go in there and I got to start asking a lot of questions. I need to create a team and bring in 30 to 50, 15 to 50 engineers to examine their systems, baseline their systems, figure it out. And now I'm with this team. I need to go with this team and I need to show this. I need to create a new technology blueprint to get that organization to its business processes goals for the future business. Now I got to work with that team and create an architecture. Now I got to present that architecture to various stakeholders of the company, get their feedback. When we get it, we got to create the documentation around the architecture. We got to sell it to the client. We got to create a statement of work. What kinds of people? We need to assess that organization's capability and readiness for change, the type of people they have, create a governance framework, create a blueprint and a statement of work of what needs to be done. And then at that point, create a change management structure. Note, every one of those things that I told you requires to human. And that's why sales reps, cloud architects, enterprise architects, AI architects, security architects, they're immune from this. Now let's look at a job that can be completely replaced. Coding jobs. Now, I'm not talking about your greatest software developers, your top 30 or 40% or 50%. They're not going anywhere. But that entry-level coder or the person that isn't an expert, that doesn't live, eat, and breathe code, that's going to go looking for code on the internet and try and tune it. AI can write code better than the bottom 50% of developers. So you're seeing software developers being laid off. How about cloud engineering? Why don't I teach cloud engineering? Why did I cancel our cloud engineering program 2 years ago? Because what does a cloud engineer do? They write Python scripts. AI can write a Python script. They write a Bash shell script. AI can write a Bash shell script. They write Windows PowerShell scripts. AI can write a Windows PowerShell script. The cloud engineer will basically write a Terraform script. AI can write a Terraform script. So here's the secret to never being outlawed by AI. Don't do anything that can be automated. Architecture can't be automated. Sales can't be automated. Management can't be automated. So get out of things that technology can do just as good as people and get into those things that celebrate your humanity, where you have to present, where you have to lead, where you have to sell. These are all architect skills, where you have to obtain information and know which questions to ask. Architect job, we're entertaining our clients. We're talking to people. We're bringing them to sporting events and dinners and drinks, building relationships. That can't be replaced. So, and you can see lots of videos on our YouTube channel on how to not to be replaced by AI. We started making them several years ago. We wrote articles in Forbes and many other places about how not to be laid off and jobs that don't get laid off. So it's all about how you plan your career and where you put it. Chris, we'll go to the next one. Thought that was important. I wanted to spend some time on it. Just going to bring this multi-part question up. Thank you for all the content and wisdom you share with us. Is federated identity used for employees that need to access the company services via the LAN and also the cloud? If not, if external users are supposed to access only systems or applications available to the cloud, then they wouldn't need to only, if external users are supposed to access only the systems and applications available to the cloud, they wouldn't need only to log onto the cloud? I'm not sure. Is there another part of this question, Chris? How would federated ID work for external users? So, are you confusing federated ID with single sign-on? Yes, you're confusing federated ID with single sign-on. So, here's federated ID. And I'll get out of Azure to make it simple and go to AWS. I have a Microsoft Active Directory server in my data center. I have a user that wants to log into a system on AWS. I have a route that goes back. They go to my data center's Active Directory server. The Active Directory server authenticates them, and that passes a token on to AWS, Identity and Access Management. And because I logged into my corporate network to my authenticated server, I am now allowed access to the systems. That's federated ID. Federated ID is also when you want to sign into a website with your Facebook profile. What happens there? What happens there is the cloud provider creates you create a trust environment with a sign in with your LinkedIn profile or your Facebook profile. You sign in via Facebook. Facebook passes on some information about you, your name and all this kind of stuff. They get it because you trust Facebook. They send it to you, and then now you have permissions to access whatever you're allowed. Typically, when you use an external identity provider like Facebook, you're not going to have access to anything major. because you're an external user, not an internal user. But federated is just, I trust you, and if somebody authenticates with you, I will trust that information. Now, single sign-on is I log into the system through the identity and access management primary system, and that enables me rights to other systems after I've already signed in. Hope that makes sense. You have an out of context question. What do I think about the Microsoft Cybersecurity Architect certification? I wouldn't waste any of my time on an AWS security certification or an Azure security certification, and here's why. They have nothing to do with architecture for the main point. They are the name of an organization's service and how would you configure that service. So architects don't do that. Which security certifications would I use? My favorite security certification is the CISSP, and I teach that to all of our students. Igor? My next favorite security certification for architects is the CISM, because that's a management level perspective of security, again, for the architect. And my favorite super intro level cloud certification is the CCSP. Now, for 99% of the people, I will say skip the CCSP and go straight to the CISSP. But, and here's the but, there's actually more cloud computing knowledge in the CCSP certification than you would typically get in any cloud provider's cloud certification, even though it's light on security. So for those reasons, I like those three. But don't waste your time. And Igor, to put it into context, I actually created a full security certification program. I was going to teach it for free. And as I was creating the certification, which I was going to teach for free, I went through it and I was like, well, there's no security here. There's no security here. There's no security here. And I felt so bad about teaching it. So Igor, when I need another sanity check in tech, I go to Mark Milovanovic. He's our chief technology officer. And I sent him the slides and he looked at it and he's like, Mike, why would we teach this? We're going to teach people the name of the cloud provider security stuff, but they won't know anything about security. And that's not us. So I'm like, yep, thank you. You got me there. How do I convince the potential customer that Azure is the right option compared to others? You're actually asking the wrong question. So here's how you sell something. You understand the customer's problem and you quantify that problem. The problem of that this business has is this business does $20 billion in sales through a global retailer. 1% of additional sales is worth $200 million to them. So you design a solution that costs $20 million that can increase their sales by 1% or $200 million. And then your customer gets there. Now, whether it's Azure or AWS or Google, well, here's the reality. It doesn't matter. So, but what you can do is you highlight what your company does. And you know, which hat are you wearing determines how you do it. If I'm working for Microsoft, I'm going to talk about the experience Microsoft has with regards to digital transformation. I'm going to talk with the knowledgeable knowledge base of people that understand Microsoft and understand Active Directory and understand many of these Microsoft directories and quotas and features, and how it's very easy and inexpensive to find lots of people that understand Microsoft compared to something else. I'm going to show that there's much more people that understand Microsoft than there might be that understand other services. Then I'm going to go down there and build a business case on why Microsoft. And I'm going to highlight what Microsoft does better. Now, if I'm an architect, I'm going to be meeting with that client every day for 6 to 12 months, right? And when I meet with that client every day for 6 to 12 months, I'm going to be taking them to lunches and dinners and drinks. And prior to the architecture going out, they're going to issue something called the request for proposal, and they're going to send it to AWS, Azure, and Google. And if I'm at Microsoft and I'm going to that client every day, I'm going to start planting seeds into that client. You know, Active Directory would really be a good solution for you here. You know, this kind of thing, which Microsoft does well, might be one of the things you really should think about from your digital transformation perspective. And then when that client issues that RFP 9 months later, the RFP is going to look like something that Microsoft was designed for versus any other cloud provider. And this is why architects don't touch the technology. We can't code, we can't configure, because we're at that high levels of the business all day, every day, learning that business, creating a strategy, helping that sales team do it, building business cases, showing why that customer is there, showing the experience that Microsoft has in providing transformation and changing business with technology. If I'd go to another company, I'd focus on what they're good at, but that's really the key. Because otherwise, it's, why should you buy a Chevy versus a Ford versus a Mercedes? Know your audience, know what they care about, and position those things there. We need to get back to the content, but you're a CS specialist 4 years, in my opinion. Is that job senior enough to get into cloud architecture? So, foolish to crow, if you've been doing engineering for 4 years, that will teach you nothing about cloud architecture. Nothing. It will teach you how to be an engineer, how to build. So, foolish to crow, I've taken people like Jennifer Ema, who was a mental health tech and with zero experience, got her first cloud job as an architect. Jermaine Houston, who basically was selling landscaping gear, his first job was an enterprise architect. Balwinder Kerr was a stay-at-home mom, but we got her hired at Microsoft. Lenny Burnett was our video editor, and we got him trained as an architect, and he got his first job at Citrix as a solution architect. For example, Arun S. was working at Home Depot. We got him his first job as a solutions architect. Ivan Tamba was a 24-year-old college student working as a waiter, got him his first job at AWS as a solution architect. Jordan Kitko was a college student, first job as a solution architect. I can go on. But I also had people like Pritipal Sejan that were engineers for 20 years, and we still had to train them to be an architect. And why? The architect has to design systems to optimize business performance. You learn none of that by working as an engineer. You learn how to build things. So I want you to understand the architect job is very like the building architect. If I wanted a brand new 100-story hotel, I call an architect. I don't call the engineers that build these or the construction workers that build these. I hire an architect, because you don't learn architecture or system design. If you take our program like you asked, I don't care if you've never worked in tech, we can train you to be an architect, and I've given you examples. And I don't care if you're like Pritipal Sejan, or Harsha, who was a cloud engineer for 10 years, we can still get you there. But the more time you spend in engineering will not give you any basis on there. And you know what happens if you get a job as a sysadmin? You learn how to be a sysadmin. It won't teach you anything about architecture. And then when you want to become an engineer years later, you're going to have to learn engineering, because that's different than systems administration. And then if you wanted to learn architecture, you'd need to go to a new training school. So learning how to fix airplane engines does not teach you how to fly the plane. How do you get an architect job? You study to be an architect. You train to be an architect, and you get one. How do you become a doctor? You go to medical school. How do you become an airplane pilot? And you don't become a flight attendant, you go to flight school. So that's really the way. I hope this makes sense. And we have to get back to the content. I'd love to talk about careers all day, but we'll do more things next week. You just discovered this training. Will I have this training session again? Or will you have recordings? The recordings are all available there, Dexter. You can go back and watch every last one of them. On our channel, you will also find a complete AWS Solutions Architect Professional and AWS Advanced Networking, a CCNA program. And we believe certification training should be free, because certification can help you get an interview, but it's not enough by itself. And we don't believe anybody should ever pay for certification training. We train people for careers, and we give away for free what our competitors charge for. All right, so let's get back to the content. Give me a hashtag AZ305. And I'll run a career webinar at least once next week. And normally speaking, we have at least once a week a question and answer session where we answer your questions about careers. So let's talk about Azure management groups. That's going to be a way to provide manage access policies and clients across multiple subscriptions. They organize your subscriptions into containers, allowing you to apply IAM policies and controls across your subscriptions. Somebody asked me a little bit about something that AWS does that's very similar, like organizations. basically speaking, you've got this hierarchical structure where you've got groups that are organized in a hierarchy, and each group contains subscriptions to other management groups. So basically speaking, you've got the ability to apply a policy at the management level and ensure that any subscriptions underneath that have their ability to be there. Management groups let you use those same role-based access control and enables you to organize your resources by grouping different subscriptions based upon criteria, business unit, department. It tends to scale very well and integrates great with Azure policy and cost management functions. Which brings us to Azure policy, and I'm sorry for all these, proprietary terms we have to talk about. Remember, this is a certification training, and what is certification predominantly? It's more about learning the names that a provider calls things. So Azure Policy is going to be a service that's going to be used to create and assign policy definitions in the Azure environment. So it's going to give you like this top level view so you can evaluate the environment, and you'll give you the ability to drill down into certain things on resources, granularity. It'll give you the ability to bring your resources into compliance through bulk remediation. And policy evaluates resources by comparing the properties of resources, meaning business rules. What does Azure Policy do? You create your policy definitions, and once they're formed, it gives you the ability to scope and see any of the resources that Azure supports. It gives you some help with regards to governance for resource consistency, regulatory compliance, security, and cost management. It helps your organization's engineers standardize operational deployment practices. It enforces how your cloud resources are configured. So it's basically giving you a little bit of here. So, if you're really looking at here, you'll be able to look at it from one perspective and see who can do what and what kind of policy you have and come up with various templates. And, that's designed to make things much easier. So let's talk about Entra ID and multi-factor authentication. So Entra ID is really going to be a cloud-based authentication service that's going to provide an additional layer of security for, say, user sign-ins and transactions. It'll require users to provide multiple forms of authentication, like a password authentication. The key is it's more than one. Why? Because if I get access to one thing, I want something else. So maybe you get a text message with a one-time password. Maybe you get a mobile app verification code. Maybe you have an OAuth hardware token. The point is, when you use more than one thing, you can go better. And with Entra ID multi-factor authentication, we've got that conditional access. So you can create policies that basically means I can just use a username and password to sign into this. But to get access to this important system, now I got to provide a token. There's also this concept of self-service. Entra ID multi-factor authentication includes some self-service capabilities that's going to allow users to configure and manage their own settings. Users will be able to enroll in an authentication method. It integrates into Entra ID, the online version of Active Directory. Why? Because that is your predominant identity and access management platform in the global enterprise in today's world. And it's Microsoft's one. It'll give you some security monitoring and reporting. So you'll be able to review reports, for example, on MFA registration status, the methods that are used. And if you think about multi-factor authentication, and when you have to deal with security frameworks and be compliant, like PCI DSS for payment cards, in the medical world, we've got HIPAA, at least in the United States. In Europe, we've got GDPR. So many of these systems require some fairly strong authentication mechanisms to safeguard privacy. So multi-factor authentication is going to help with that. And obviously, we can integrate it with so many different Azure services. So, I always loved multi-factor authentication because you've got a user that wants to do something. We can look at their device and what they've access to, and we can actually verify things each time. Or we can say you're accessing something that really matters, require MFA. Send a text message with a one-time code or a token, respond to the challenge, and poof, you're in. So let's talk about Azure Key Vault. Azure Key Vault is going to be a service that's going to be offered by Microsoft that will securely store and manage your encryption keys, your secrets. So, AWS has their place where you store your secrets. Azure Key Vault is where you store your secrets, like a database string or a license information or any kind of secrets or cryptographic key you may have. It's going to enable you to store your cryptographic keys for encryption and decryption, any kind of API keys that you have or API secrets. You can store various things about your SSL TLS-based certificates that are here. It integrates very well with other Azure services. And of course, you can use access control to be able to access this. And we can work with hardware security modules as well. Okay, so the next section is going to be applications and services. So now we're going to be getting involved in a lot of the proprietary stuff that we have. And what I'm noticing is we're getting a lot of career questions that are popping in. And some other questions that are starting to pop in that are outside of this. I think we're going to finish a little early tomorrow based upon the pace that we're at. So if we finish early tomorrow, maybe we'll have an hour and a half to answer career questions if you desire. And I'm more than happy to do that because I think we'll finish tomorrow probably around 3:30 to 4 p.m. So now we're going to start talking about a lot of different Azure stuff. So we'll talk about managed applications, queue storage, storage bus, logical apps, HD Insights, Stream Analytics, Event Hubs, Azure Kubernetes Service, Monitor, Application Insights, Activity Logs, Cognitive Services, Resource Managers, Bicep, VM extensions, and automation. So what is Azure Managed Applications? Well, Azure Managed Applications is going to be a service that's going to be provided by Azure that's going to allow independent software vendors, managed service providers, and enterprise IT teams to deliver and manage applications and services as a full solution inside of the Azure Marketplace. So let's say you needed a firewall, an enterprise-grade firewall. Let's face it, I'm not going to be using it in AWS WAF and Azure WAF. I'm going to be using something from a firewall vendor like Palo Alto, Fortinet, Cisco, Checkpoint, one of them, the big security specialists. And in a normal environment, I call Cisco, they ship me some firewalls, I rack and stack them in the data center, or some technician racks and stacks them in there, and we configure them. I can't rack and stack anything in the cloud provider's data center. So when I want an industrial grade thing, maybe I need a load balancer with more functionality, like a reverse proxy. F5 makes them. I go to the marketplace and I get a managed offering. Comes on a virtual machine, I use it. I get a Checkpoint firewall directly from the marketplace, a Palo Alto firewall from the marketplace. So these managed applications are going to be pre-configured and that are there. But you as an organization could also create and sell your own Azure managed applications as well. So they're going to be pre-packaged things in the marketplace. You can create them and sell them. And if you're a software vendor, you might. Or you could actually buy these if you're an end customer and you want something good or enterprise grade. So with regards to managed applications, imagine this. Opportunity one is you get your virtual machine and then you install the routing code from the routing provider if they'd sell it to you, which in many cases they don't. Option two You go to the marketplace and you click start, and it's up and running. So, very simplified deployment. There's going to be a catalog of pre-configured solutions that you can get tailored or customized for your needs. How many cores do you need on your firewall? How much DRAM do you need on your firewall? That kind of thing. These things will have a managed lifecycle. So the people that are creating these specifically Azure managed applications are going to be responsible for managing the lifecycle of your application. That means they'll be releasing patches and maintenance schedules for you. It basically gives you the ability to deploy certain things with good level of control that are pre-made for you. And because we're basically, typically speaking, getting a virtual machine with the software on it, these are metered applications. They support flexible billing models. They enable the service providers to define a core pricing, and you're going to be billed directly through your Azure subscription. Just like on your phone, I get billed for a couple of services directly from the Apple Store. Oh, that's my cat, by the way, little Cindy, in case anybody likes cats, but that's neither here nor there. So that's what we're kind of talking about. You're going to get billed directly from there. So I tend to love the way these managed applications work. Next thing we're going to talk about queue storage. Well, we talked about queues on the first day. And there's lots of queues we can use. Now, if we're dealing with a multi-cloud environment, we're not going to be using an Azure queue or an AWS SQS queue. We're probably going to use an Apache Kafka queue because we can have similar things that will sit in all clouds. And we can use an Apache Kafka queue on a virtual machine. But if we were going to be directly in a single environment, we could use Azure Queue Storage, which is basically a queue service. You can go back to day 1 or day 2 when we talked about databases and queuing, that you can store your messages in and receivers can receive them to make your systems go. Now we have the concept of a message queue. So maybe you're going from your application server to your database server and you don't want to drop messages. So straight from the application server, you pop it in the queue. And when it's ready to be used, it gets pulled from the queue. And we're talking about any kind of message for the most part you can think about. It can be XML data, text data, JSON data, binary data. The only limitation here is that each message is going to have a maximum of 64 kilobytes. Now, 64 kilobytes is a pretty good amount for a message. Not for a photo, but definitely for a piece of text, that kind of thing. And Azure Queue Storage is going to be really a feature of Azure storage accounts, which are going to be scalable solutions by Azure. Basically, you're going to create your queue storage containers inside of your Azure account. And then you'll basically be organizing your message queues for whatever your applications. You may have some message queues for your microservice-based things. You may have a different kind of message queue that you might have for your databases. And Azure Queue Storage is asynchronous, meaning pop the message into the queue and you remove it from the queue, or it gets removed from the queue when there's capacity. Azure Queue Storage, for the most part, is first in and first out. So message 1 goes before message 2. Message 2 goes before message 3. That's FIFO, or first in, first out. And generally speaking, Azure Queue Storage guarantees that every message is going to be delivered at least once. So your messages should go through. If it pops up on a test, there's a concept of a visibility timeout. But that really is when a customer dequeues a message from the queue, it's going to become invisible to other consumers for a configurable visibility timeout period. So others won't be able to see it. And if the message is not deleted or processed, then it'll become visible again. So the point is it's going to get to where it's supposed to. And these message queues in Azure Queue Storage tend to be fairly scalable, because they're made by the cloud providers, and they tend to be the ability to flex, increase in size or decrease in size as necessary. And they have the ability to handle millions of messages per second. And they provide very good low latency access to messages. The only thing to think about is, are you multi-cloud? And if so, don't use a proprietary queuing solution. And 98% of businesses are multi-cloud. Are you single cloud? Take advantage of something that's pre-made for you, and it's simple and elegant. So they're going to be what your decisions are. Here's your goal with something like this. The sender sends it to the queue, and the people that need it pull the message from the queue if and when they need access to messages. So that's one type of queue. Now, the next type of queue is the Azure Service Bus queue. What is that? It's another messaging service designed to promote reliable communication between applications or components or devices. So it's good for transactional messaging. The Azure Service Bus queue is going to support transactional processing, allowing you to send messages in the context of a transaction. So this is going to ensure that messages will be processed successfully or rolled back in the case of the failure or the message doesn't get there. So the message is going to come through with the integrity of the message in place. And when you're using these distributed systems that are fully spread out, you need to make sure messages don't get lost. So message properties and headers. Messages in the Azure Service Bus queue can include custom profiles and headers, allowing you to basically attach metadata or extra information to the messages, whether that be for routing them, for filtering them, or processing them. And this gives you the ability to create some pretty advanced logic on your messages and where they're going to go based upon your workflow. Service Bus queue also has a dead letter queue. So let me explain what a dead letter queue is. It comes from the post office. Let's say I wanted to send a letter to Muhammad B over there, who's over there in Somalia. And I send the letter and it gets received by Muhammad B and B's post office in Somalia. And they can't figure out how to get it to Muhammad's house. So they store it into this dead letter queue, meaning they save the letter. And at some point, if Muhammad were to come into the post office and say, hey, do you, or whatever the post office equivalent is that he's working with, do you have access to a letter from me? Let me check. And they find there's a box that has it. So we often use that same concept in technology systems. We create a dead letter queue. So we've got a message. It gets stored. If it can't be delivered, it's popped in the dead letter queue. So then you still have access to the message later, and you can see what failed and why it failed, so you can fix the system. Azure Service Bus queue also gives you the ability to create what's called the time to live, or when the message is going to be expired. So maybe you don't want messages hanging around forever. And if it's not been delivered in a certain period of time, delete it. And you can do that too. Now, because it's cloud managed, all these systems can pretty much scale and manage dynamically for you. Millions of messages per second, partitioning across a wide variety of nodes. And, this is going to be integrated with a lot of your development things, specifically microservices and multi-tiered architectures. You got a sender. You can pop it into a queue, and it can be delivered to multiple different receivers along the way. For example, over here, maybe you've got 3 subscriptions to the message. And lots of time we've got messages that have to be delivered. For example, we may have a message that sends something to one server for processing. Another message sends, say, a notification email to the customer. We got your whatever, it's uploaded, we're going to process it. So that's the kind of thing where we may need to fan out or deliver multiple messages in a subscription. Next is Azure Logic Apps. So what is that? Azure Logic Apps is going to be a cloud-based service that's designed by Microsoft Azure that's going to enable you to automate workflows and integrate various applications, data, and services across your cloud and on-premise environments. So it enables you to create some workflow automation. So you can design and automate a workflow. You can create workflows by using a connection of pre-built connections and triggers. By doing so, it enables you to provide a wide range of connectors that you can integrate with lots of things. Some SaaS applications, some on-premise application systems, some databases, some APIs. And basically, you can create a trigger. So maybe you've got an HTTP request. or a timer, or a file system event, or a message queue, or a webhook notification. And in response to this, you're going to define an action. This happens next, for example. That's really what we're talking about here. And the key with Azure Logic apps is it's pretty simple to set up. You don't even need to know how to code. It's got this beautiful little graphics designer. Step 1 should happen, then step 2 should happen, step 3. You kind of drag and drop it, and it writes the code behind the scenes for you. As you can see, we're getting into a lot of these no-code and low-code and AI-driven coding solutions, which is one of the reasons I typically caution people against things related to software development careers. Now, we also have lots of templates that are pre-made, so there's going to be a gallery of so many wonderful things that we can look at, and templates to integrate various things. And we can be integrating Office 365 and Salesforce and Twitter and all these kinds of things. It's pretty nice and easy to set up. And it obviously provides a way for us to manage it. And because it's managed for us, it tends to be scalable and resilient because, Azure is going to build in a lot of excess capacity to their systems. And it meets the normal security standards, role-based access control, encryption at rest and in transit, network isolation, follows security standards like ISO 27001, GDPR, HIPAA. And it's serverless. Well, with serverless, you're not managing servers. That could be a good thing or a bad thing based upon cost. But if you use it a lot, serverless gets real expensive. If you don't use it at all, serverless is typically much cheaper. But in this particular case, you're creating a workflow. It's going to be managed more dynamically for you. It's really something more like this. We go to the app, we create a trigger. The trigger could be anything. Somebody purchases something. Then what do we want to happen? What's the next phase? What's the next phase? And we can schedule it all out. I always thought this was great. Azure HD Insight. So Azure HD Insight is going to be a cloud-based big data analytics service provided by Azure. It's going to enable you to do the following: deploy, manage, and scale big data frameworks like Apache Hadoop, Apache Spark, HBase, any of these big data frameworks. It's going to provide open source analytics. So we're going to lots of analytics that we can work with. And it's fully managed for you. So fully managed big data framework. It's going to provide enterprise grade security, meaning you can integrate it into your systems. You integrate it with Azure AD, Entra ID. You need a secret decoder ring to remember what these people actually, what all the companies make up their marketing teams, the name for these sort of things. So we've got our role-based access control, our strong IAM, and it's going to give you scalability and flexibility because it moves up and down. These are big data clusters for big data processing. And because we're dealing with big data processing, we're going to be dealing with our big data sources. So we might be integrating with object storage like Blob, Azure Data Lake storage, maybe your Azure SQL databases, maybe your Synapse Analytics, which used to be called SQL Data Warehouse, Azure Databricks, Azure Machine Learning, and visualization tools like Power BI. The key is it's pretty managed for you, it's pretty simple, and integrates to so many tools. And generally speaking, there's lots of big data frameworks, and this, for the most part, uses lots of them. You may be familiar with Apache Hive or Apache Pig or Apache HBase or Apache Storm or Apache Kafka, Apache Spark and Python and R and all this other .NET stuff and Java and Scala. So your big data engineers, your data scientists, your developers, they're going to have access to a lot of tools. Because it's got access to all these frameworks, you can pretty much customize it with custom scripts or libraries. It's got tools for you to monitor and manage these systems. And it basically uses this concept of a cost-effective pricing model. Theoretically, if you believe in cloud serverless stuff being cost-effective, you pay as you go. You pay for the resources that you consume. So you pay for your compute, your storage, what have you. Now, the key here is there's no upfront costs. But anytime you're paying for a service, if there's no upfront costs, you typically pay much more operationally to use these systems. Azure Stream Analytics. So Azure Stream Analytics is going to be a fully managed, real-time event streaming and processing type service. It's really designed to enable you to ingest, process, analyze, and derive data from your sources. So if you're familiar with AWS and Kinesis Analytics, it's pretty much the same kind of thing that we're actually talking about. But what's the point of these real-time analytics platforms? And why is it so interesting in architecture? Well, without this, I collect data for a long period of time, right? And then I've got my data. I look through my data years from now, and I make business decisions based upon the data. And that's good. But the whole point of real-time analytics is you got information coming in. And based upon the information you get, you can communicate. Kind of like if you were giving a presentation in front of an audience of a few thousand people, for those of us that do it. If the audience looks like they're falling asleep, you're going to change your behavior because you're going to look at the audience. If the audience is up and clapping, you're going to do more of what you do. Well, businesses, the better information they actually have, the better you're going to do. So Stream Analytics will help with real-time data ingestion. And you can get your data from lots of streaming sources like Event Hub, notifications, Azure IoT stuff coming in, lots of things. And it can support structured data and semi-structured formats like JSON or CSV. Now, because most people are used to SQL, and this is like a data analytics database services, you can run SQL-based queries, that structured query language, which is going to make it much more user-friendly to people. We have the ability to do windowing and time-based processing. What that actually means is you can define a sliding or tumbling windows or variable windows and variable durations. So you can collect information over a period of time or events. And of course, we've got this Azure Stream Analytics, and we got all these tools like Event Hubs, IoT Hub, Azure Functions, SQL Databases, Power BI. And when we're using cloud native with other cloud native tools like these or these proprietary tools, it becomes very simple and elegant to use the cloud provider's tools. It really does. It just makes it harder when we're multi-cloud. So we can use this. It tends to scale well. We can integrate it with some machine learning or artificial intelligence tools. And realistically speaking, what's going on here? Well, we can pull in data or ingest it from lots of sources. Log files, maybe clickstream information coming off of a website. Maybe we've got 1,000,001 of these IoT devices doing weather. Maybe a company's got a whole lot of business applications. So that brings it in, and then we can analyze that information, and now we can do something about it. So really great stuff here. I'll probably cover Azure Event Hubs, and then after Azure Event Hubs, I'll probably stop and take some questions. So what is Azure Event Hubs? Well, it's going to be a fully managed real-time data ingestion service provided by Azure. And it's going to enable you to ingest, process, and store large volumes of streaming data from a lot of environments. It will enable us to ingest millions of high throughput event-based data streams from millions and millions of devices. It tends to be scalable and provides very high throughput. So realistically speaking, it's going to give you what you need. Tends to be low latency, lots of events that it can deal with. It's kind of interesting that it can actually partition your information. So we can take the stream that's coming in and send it into multiple partitions, so we can parallel process it if we wanted to amongst different systems. We could load share it amongst different systems. And with regards to retention and durability, what we're dealing with is Azure Event Hubs is going to provide configurable retention policies. So you'll be able to store streaming data for a specified period. This will help with replayability of events and analytics and troubleshooting and auditing purposes. It will enable us to capture and integrate various systems. So it's going to have some built-in integration with Blob, meaning object storage, data lake storage. So basically you can capture and store your streaming data in an easy and an elegant manner. And of course, it's going to provide some good security features like role-based access control and network isolation. So it will work with the ISO type standards or HIPAA standards or SOC standards or GDPR standards. It provides multi-protocol support. So lots of things that you could use for ingestion, whether it be HTTPS, Kafka, message queue type technologies. So it's all about connecting and interacting with your Event Hub messaging in any kind of programming language you want. I think I'm going to stop here and open the room for questions. I think we should finish tomorrow around 3:45. And what I'll do is I'll stay till 5 o'clock and answer career questions, because it looked like there was a lot of them tomorrow. A lot of them, and I want to make sure we do them. We always, at least once a week, do free career question and answer sessions. But I don't necessarily have the ability to present for a couple hours and then do a couple hours more questions each day, in addition to all those other things that I do each day for the voice perspective. So I'll definitely dedicate an hour to an hour and a half tomorrow based upon when we finish. But let's try to get to your questions now, because we really want to help you. I hope you guys are all learning a lot. And if you are, give me a hashtag that says AZ305 or happy or something like that. Okay. Is BGP dynamic routing UDF? I'm not sure what UDF is. You mean UDR? Okay. Is BGP dynamic routing UDR consider static routing? Not sure if the statement is right. So, unfortunately, I don't actually understand what you're asking. So maybe ask your question in a different way. But realistically speaking, UDR is more about. Actually, I'm not. I need to really understand the question a little better. Mark, if you understand the question, Mark is my chief technology officer. Please answer that, because I don't really understand the question, and I don't want to misanswer it. Oh, you do user-defined routing. Okay, so some guidance I can give you all is not to use acronyms, because all these acronyms can mean different things to say different people. And UC means unified communications, but it can mean something else to somebody else. Somebody told me they were an EA, and I thought they were an executive assistant, because that's the standard definition of an EA. So BGP is dynamic, and it's going to automatically adjust based upon dynamic changes. Something goes up, some network layer, a BGP update message is sent to basically remove some information. Now, user-defined routing is where you tell it where to go, and that's generally you manually configure it, and it's not going to change automatically. So We're really talking about two different sets of things that we're actually asking about. Now, you can configure a BGP policy to engineer your traffic one way versus another, but if the primary link goes down, it'll recalculate. So I wasn't sure you meant user-defined routing. Sorry. Is there an architecture scenario for using hybrid connectivity using ExpressRoute? Yeah, lots of them. Using software authentication, example, Microsoft or Google for MFA. So now I'm not understanding the question. Are there lots of use cases to use hybrid connectivity? Yeah. Well, look at it this way. Generally speaking, your lowest cost, highest performance, lowest latency, and highest security is in your data center for systems that run 24 hours a day, 7 days a week. So in that particular situation, what you're actually dealing with is put your frequently accessed stuff in the data center and then move to the cloud. Now, I'm not sure. It's also possible that you've got a data center locally and you've got lots and lots and lots of users there. And when you want someone to access to a system on the cloud, they run back to Microsoft Active Directory and then get authenticated for cloud. You could do that. Or you could federate your organization's identity and access management strategies in the data center with something else in the cloud. So you can log into the cloud and get authenticated, or you can log into your AD structure in the data center and get authenticated to the cloud. So generally speaking, you probably do more of that. But I'm not sure I understand more of your question. But there's lots of reasons you could use Azure AD to deal with your data center and provide its authentication. You have this concept of this Azure AD Connect that we used to talk about to connect Azure IAM with your local data center. So yeah, there's lots of reasons to do this, and there's lots of good reasons why organizations will really should do these things. Chris, we go to the next one. What is RabbitMQ and the storage queue? So RabbitMQ is going to be a message broker that's going to basically facilitate communication between your applications and the devices that need there. So the multiple parts of your applications in a distributed application. RabbitMQ is going to send your messages and manage it into and out of a queue to make sure your messages go there. Azure Storage Queue is going to be a cloud provider proprietary queue, which means it's going to be simpler to set up, and it's designed for storing and retrieving messages, and it will help decouple environments. But you have to think of it this way. Azure Storage Queue is going to be made by the cloud provider. And what's the cloud provider business? A billion and one different things. RabbitMQ is a standards-based message queue that you can deploy everywhere. So it's going to have more features and functionality than the Azure one. Generally speaking, the industrial tools will always give you better features and functionality than the cloud provider ones. And here's the reason why. So, if you get a Swiss Army knife and it's got a little blade and a little wine opener and a little screwdriver and a little toenail clippers, it's going to have a knife, but it's not going to be a great knife. Now, if you're camping and you needed to chop down a tree with the knife that you actually were given in your Swiss Army knife, it's not going to be pretty. By comparison, if you bought a good knife that was made out of good, strong steel that was, say, $200, and it's got a 5-inch blade and a good handle, the $200 that went into that knife that was made to get you through survival situations, camping, build your house, do whatever you need, it's going to be better than you got in the Swiss Army knife. You have to remember that cloud providers are in the Swiss Army knife business. They do a little bit of everything. So whenever we want something bigger, we're going to get greater security products in general from a Palo Alto, a security company, or a Checkpoint security company than we'll get from the cloud provider because that's their only business. Same thing for any of these things. What's the difference between HD Insight and Synapse? So, HD Insight's more of a cloud service for managing open source big data frameworks like Hadoop or Spark or Kafka. Azure Synapse is more of an analytics type platform that's going to integrate big data, data warehousing. So it's more of an analytics platform, whereas HD Insight is more of a big data analysis tool. HD Insight typically focuses on with open source big data tools. What's the equivalent of the Kinesis data stream and data firehose? So Kinesis data stream is kind of like Azure Event Hubs. Kinesis data firehose is similar to Azure Stream Analytics. There's a really good document on the Google website, and I actually love it because Google's marketing department spends lots of money in this, and what they do is they compare the AWS service name, the Azure service name, and the Google service name, and that way, realistically speaking, you don't have to be able to remember all these crazy things in your head. It's pretty easy to search Google AWS Azure equivalents, and you'll find it pretty quickly, and they always update it. What are some third-party multi-cloud analytics tools? Well, I'll tell you right now, as a rule, I'm not on the monitoring side of things, but Splunk is a great real-time cloud analytics tool and log management tool. Snowflake has some things with regards to their Sumo Logic is another cloud native monitoring and log analytics tool. Datadog is another one that you can use to monitor analytics across companies. But that's not my area of expertise. You want to be a security architect. You want to be a security architect one day being an expert in Azure. Currently working as a cloud security analyst, what's the best route for me? So first, don't try to be an expert in Azure. If you do, there will be no jobs available for you as a security expert. Why? 98% of organizations are multi-cloud. So if you're focusing on Azure, you can only work for 2% of the companies in the entire world. I don't recommend that. So what do? If you want to be a a security architect, what you focus is on security architecture. And I train a lot of security architects. So what goes into security architecture? Well, it's not how to. You won't learn it as a security analyst, and you won't learn it as a security engineer. You'll have to learn security architect training. And what goes into security architect training? We train lots of security architects in our cloud architect program because I have such a heavy security background. Well, the first thing you need to learn is how do you quantify an organization's assets and risk? Because nobody's going to protect something if they don't know what it is. So what is the risk exposure? You have to help that client determine, should they manage the risk? Should they transfer the risk with regards to insurity? What is their current risk exposure? And there's lots of calculations which we teach on how to do that. So first, you need to know what assets you have and what you're protecting. Again, none of this stuff is cloud specific. The next thing you need to determine is what your overarching security policy is, because as a security architect, you're going to create security policies. And you won't learn this by configuring firewalls. Security policy is one, does your end-to-end encryption strategy look like? What is the organization's identity and access management strategy like? What minimum level of security do we need on our virtual machines? What type of security do we need in storage? How do we manage the network security? So there's that. That's another thing that we would do as security architect. Then you would need to learn about your frameworks. When to use zero trust, when to use defense in depth, why do you need to use a combination of both? Should you use NIST framework? Should you use this framework? So that's a lot of what we do. Then a lot of it is about, just how do your demilitarized zones need to be designed? How would you secure your endpoints and what needs to occur in that? That's some of the things that would go into security architecture. Part of that is understanding what your application security architecture is. What do your software developers need to do on their applications when they create them? Things like input validation, for example. And of course, we teach these kind of things. So these are the kind of things that go into security architecture. So in order to learn security architecture, you will still need to learn the underlying systems, the network and the data center systems. Meaning, if you understand virtual machines, it doesn't matter if they're in the data center because you're going to be working on them there. It doesn't matter if they're going to be in the cloud because you're going to be working on them there. So it's not about being an expert in Azure. It's about being an expert in the technology and how the systems talk to each other and how the systems integrate and how you would protect an organization without messing up their business processes, which you can do easily with security, without messing up their ability to earn a living. So I've trained lots of security architects and they're working everywhere. So there's that. But if your focus is on Azure, you're going to miss the boat. Now, I tell people that if you only know one cloud, there's no jobs for you. And here's the reason. Nobody is using a single cloud except for 2% of the businesses enterprise-wide. And who hires security architects? Big governments, big business. And if somebody's going to pay you $200,000 to $300,000 a year or more, they need to understand that you're there. So you'll have to understand that. Additionally, in addition to that, it's not going to be enough to learn the tech. You're going to have to learn how to speak to the C-suite and understand their needs. That's something called CXO relevancy. You're going to have to learn how to give good presentations. And obviously we train these, but wherever you're at, if you're not training with us, get your presentation skills. You're going to have to get some business process re-engineering skills. As architects, we lead teams of 15 to 50 people. So you're going to have to develop the leadership skills to make people want to work with you for the entire project. You're going to have to be able to quantify the business problem and quantify the security solution so you can help sell it. You're going to be creating strategic blueprints. You're going to be managing and negotiating with security vendors because it's not going to be Azure. I mean, you may be on Azure, you may be on AWS and Google all at the same time. And then you're going to be getting some security stuff from Cisco and other security stuff from Palo Alto and other security stuff from Fortinet, other endpoint protection, which you'll have to determine the anti-malware, those kind of things. So I kind of hope that answers the question. You will need architect training, which is a combination of the designing of what we do, the leadership of what we do, the business acumen of what we do, the sales skills. So join us on our next How to Become Your First Architect webinar, and I will happily get into this in depth, in real depth. But we have to make sure you're focused on security and not any particular cloud. Because do you want to learn how to drive a car or do you want to learn how to drive a Toyota? How do you get architecture-specific training? The only people that I know that provide any architecture-specific training right now are me and David Lithicum. David provides short-form architecture, like a small video here, a small video here, a small video there. David Lithicum also works with us, by the way, and he creates our AI learning thing. So, you know, when you're creating an architecture program, you're going to need to learn the business skills, the leadership skills, the technical skills, what have you. And if you're only getting the technical skills, you can't be there. So, you know, you're going to need these skills. So let's talk about the kind of skills you're honestly going to need. The first is the architect job is not a hands-on job. We don't code. So you'll need to learn how to sell because nobody wakes up and says, you know, I want to buy this stuff. You have to sell it to them. You'll have to be trained in how to ask the right questions. Of course, we do this. What questions do you need? You're going to be presenting at conferences, at executive briefings, presenting to customers. So you're going to need training in that. You're going to be doing a lot of executive writing and writing white papers and respond to RFPs. You're going to need training on how to do that. You're going to need training in how to lead a large team of people. You're going to have to get training in how do you build the business case, because nobody wakes up and says, Mike, I want to spend $200 million on security solutions, but you'll be selling and designing $200 million of security solutions by learning how to build the business case and quantify the security risk. You will need to learn business, and that's why we teach business acumen. And quite frankly, this is why we retrain everybody else's graduates, because they don't teach this. Then you will need to learn the security, not how to, but how to design and integrate it. And really, that's what's going on. So, when do you use this? When do you use this? When do you use this? We have a webinar, and this is all we do is architect training. We don't focus on any other skill. And that's why you may notice as we're talking about things, and honestly, our architecture training is about 800 to 900 hours. But you notice we're talking about what it is, where it's going to impact the business, how it would be used. And I'm saying, look, you can go download those labs and do them on your own, but you can do labs all day long and you're not there. So kind of hope that makes sense. But that's all we do. David Lithicum provides really good architecture training. In fact, David Lithicum works with us. He helps teach some of our cloud architect students. He also teaches our AI architects, and our focus is architects. You got to learn for somebody that's been an architect, that made it to the top, that knows what architects actually do. Or else you've got to do what I did, which is basically get an MBA, take all this kind of training, and then try to figure it out, which is unfortunately what I had to do. And I made a lot of mistakes along the way 25 years ago. When I finally figured it out, I spent the last 2 decades training architects predominantly. It's the best career, I'll tell you that. You'll love it. And we'll end early tomorrow. So I'll answer architect training things if you desire, because I really want to help anybody that wants a career. Whether you train with us, great. If not, if you know what skills to learn, I'm still happy. I just want you to be able to get the jobs and build the career you want. That's all I care. Anything? All right. Well, if they're not, if you've had a good time today, maybe hit the like button. If you're not a subscriber, please subscribe and hit the bell to be notified of new things, because we do lots of free stuff coming up for you guys. We want to do everything we can to help the community. I've been in tech now for, well, more than 25 years. And ever since I left internal medicine for tech, it's been the best thing I've ever done. So maybe give me a hashtag AZ305, and I'll see you tomorrow. I've enjoyed spending time with you. Love to get to know more of you. We'll have a webinar on next week where we discuss architecture roles of some kind on Zoom, where you can also ask more questions. And as soon as this training is done, we will get back to answering career questions. Usually Mark Milovanovic, our Chief Technology Officer, who's also a Cisco certified internet expert, comes on. I come on since we've had a lot of tech careers, and we're happy to answer your questions completely free.